I don't know how I'm going to get my slides to DJ3 Vanda.
We said email the slides if this isn't working.
Yeah. Here, let me.
Okay, so you're back to straight plugged in.
Okay.
I believe, right?
Okay, but it's right now writing to this screen, so we'll see.
All right, so I'll let you be. You're just going straight from here to here.
Okay, that's a tragedy. How's my audio? Good.
Unless you have your backup computer on track.
I just sent my friend to go try the backup computer. I do not own the backup computer.
No worries.
Okay.
Yes. You know, students, free furniture. They were right. I could find a way to go back. And it was end of life.
No, it's not detecting it. Oh no, now I can be heard. Okay, sudo ifconfig wn0 nwid BSDCan WPA key. I can hear me through the entire room.
When I took that down, I sat down in front of an IBM 37
Do I see network? I see network.
Well, that was the irony. The irony was my uncle worked for Bell. Well, before I got to university, I thought, why did I come to university? I'm going back.
Well, this. Perfect. Do I have a terminal? Command space. Terminal. I don't have a key on here. Oh, how am I going to get to my mail? I mean, I know how to get to my mail, but I don't want to get to my mail. Oh, I know what I can do. Dash J.
Yeah. Does anyone have a USB-C HDMI dongle?
I have to.
Oh, you do?
I almost brought one, but
Sweet.
I decided to bring the dongle for this computer.
Let's go.
Okay. Not quite.
I'm not sure what he's running on here, but we got a Mac as the backup computer. But now we can't plug HDMI into it because Max thought we didn't need those anymore.
Really? I mean, the MacBook Pro would have it.
How do I present this?
Here you go.
I just wait for the light.
Here, I'll help you with this.
Thank you. I've never actually made it into presentation.
Enter full screen.
And there we go.
Okay, do we have output? We good?
Combinations are the same for that approach.
The projector is indeed able to do that. What? Oh, shoot, that was the wrong computer. Whoops. Do not shut down your web server remotely while at BSDCan. Just a piece of advice for everybody. Especially when you're presenting your slides off your web server. Oh, shoot. Oh, that looks good. Will it work?
Now from output to here, output to here. Yep.
also a user, so that just to everything is a little extra.
We're not getting the slides on.
Yeah.
It should come back now.
Yeah, so far it has not.
This guy knows music.
This is a new laptop, yeah.
Oh, USB-C?
Yeah.
Have one of those. We should have one of those cables right here.
That's HDMI.
So it works going directly from there to here.
I see.
Just when you go through the machine, it gets bad.
Okay.
Oh, here, I'll give that back too.
Well, let's not give it back quite yet. I have a feeling this might be having a fun day.
Yeah. I have another one. Let's
Good.
swap it out.
Okay.
2 seconds.
Okay. I'm gonna get a drink. I'll be right back. Just a shot of vodka. Where's the water fountain? Shoot. Whoa! Whoa! Thank you.
For the win.
Thanks.
Love you.
Okay. Am I late? I think I'm late.
Have a good time.
Thanks. So, don't start advancing by, oh no. That's what I get for putting things in slideshow mode. Okay, hello. Am I good to go? Okay, hello. I'm Sean Howard. I am talking about OpenBSD and blindness. If you do not want to be listening to OpenBSD and blindness, you're in the wrong room. Hopefully, you're now late for a talk, unfortunately. Again, I'm Sean Howard. I am not a software developer. I mostly do security work in my daily life. I started as an ISP grunt. I did a lot of sysadminning work. I don't know anything about the topic I am talking about. I don't write a lot of software. I don't do any accessibility work. But I do care a lot about being able to see. So when I was going to go blind, I decided to, as something to do while I was blind, write a BSDCan talk, which I don't know if that's masochism or wisdom. It's one of the two. However, at some point in your life, you will become disabled. That might be because you smacked your head into something. It might be because you broke your leg. It might be because you are forced to carry something very heavy. Accessibility tools will always help you in some way. At some point in your life, you'll go, wow, I'm so glad this elevator was here. Oof, I'm super glad the screen reader is here. While we were setting up the presentation, we actually had a whole bunch of issues, you all saw, but I actually used my screen reader a whole bunch to confirm the computer was actually running. I could not see the screen. I wasn't blind, but I was in some way disabled. It's going to happen to somebody in your community. It's going to happen to somebody in this community. At some point, people that you respect or people you really want to do things are going to need accessibility tools. And so I do think it is worth talking about. It doesn't matter kind of why we need accessibility tools, but we need to talk about them. Accessibility tools are also, they are not universal, and an accessibility tool that helps one group might hurt another group. A good example is a lot of people have a lot of opinions about captioning images on social media right now. And that can be complicated because people with a lot of anxiety feel a lot of anxiety captioning images. I feel a lot of anxiety captioning an image. I actually feel a little more confident after going blind temporarily, but those kinds of shared accessibility conversations can be very complicated to have. I am hoping that I can try to convince other people to talk about these things. I also think that OpenBSD itself needs to have these conversations. We are an aging community, unfortunately. I think there are lots of new blood coming in, but I think there's also a lot of people who are getting older. A lot of people that I deeply respect are getting older. And I want to make sure that we can help people who are starting to find more limitations and help having those conversations. I don't know what that's going to look like. I don't think that the stuff I'm doing is necessarily good. But that's kind of my accessibility preamble. So I wanted to define the terms OpenBSD, temporary, and blindness. So first off, I'm defining OpenBSD. I hope you know what OpenBSD is. If you don't, please raise your hand. But I'm trying to run OpenBSD. I'm trying to run OpenBSD as an OpenBSD user. I have used OpenBSD as my primary desktop for 16 years now. Most of the laptops or desktops I run have run OpenBSD as their operating system on the front end, but I'm not talking about like your mother, your friend, oh, I have a friend who's blind, let's get them on OpenBSD. Oh, I have a parent with failing vision who's not technically savvy, let's get them on OpenBSD. This is not that talk. I'm going to talk a lot about like, hey, and then I tried to compile this tool and it failed on OpenBSD, and I don't know why. Somebody figure that out, please. It's not a talk about the generic form. Temporary. I was only blind for 2 days. I had eye surgery on March 2nd, and I was able to see by March 5th or 6th. So the surgery happened. I wasn't mostly blind on that day. I was blind for 2 days, and then by the 6th, I was fully able to see. My vision was returning. My eye surgery caused me to not be able to open my eyes. Explain my eye surgery. I had a disease called keratoconus. If your prescription changes, like every time you see your eye doctor, get yourself checked for keratoconus. Your cornea gets thin, and your eye starts to bulge a little. Your lens can crack if you have keratoconus. It's really bad. But back in 2016, they came up with a surgery where they take the front of your cornea off, and then they put B12 drops in your eyeballs, and they harden them with UV light. So they give you an Ativan, like just a mild anti-anxiety medication, throw you down on a table, put some numbing drops in your eyes, and scrape the front of your eyes off. Sorry. It's terrifying. I apologize. I should have warned people as much. I was going to say this. And then you lie on a table, and for 40 minutes, a doctor every 2 minutes drips drops in your eyes. And then for the last 10 minutes, they turn a high-powered UV light in your eyes and then close it, high-powered UV light. They put the clockwork orange things in so you can't close your eyes. It is not pleasant, and obviously your eyes are burned and cut. You cannot open them without excruciating pain for 2 days. I had to put eye drops in, and I would cry every time I did. So it was not fun, but it was not like, I didn't have low vision, or, because like a lot of people you'll know who are blind might be able to see blurs or might be able to see like shapes or colors, yeah. But I could not open my eyes. I was stuck like this, and I was in excruciating pain if I went any other way. So just very different than a lot of blindnesses you'll see. So obviously, I had time to prepare for being blind, which was very different than a lot of people who are going blind. When other people go blind, they might have 0 warning. They might have minutes of warning. So there's that. Some people might have years of warning that they are going blind, and I hope if you ever go blind that it is how you get it. But I found out when the surgery was in November, and I had the surgery in March. So obviously I had about 5 months to prepare, which is just enough time to waste. It is not enough time to actually prep. It is enough time to go, oh, I have plenty of time for way too long. That puts me in a very different position than a lot of people. So I started immediately to think about these things. I figured if I couldn't get a screen reader working, I probably couldn't use a system at all. If I didn't have a web browser, it probably wouldn't work. I really wanted something to work with the Fediverse, which would probably be the browser. I'm on the Fediverse a lot. I would really want a mail client. I'd like to be able to send and receive mail client. I wanted something to do, which was either going to be an audiobook or a text adventure, and I don't like audiobooks. I like podcasts, but not audiobooks. So I really wanted to do some sort of interactive fiction. I wanted an XMPP client. If you ever want to bug Steven right there, he'll make your phone into XMPP if you want, for money. But like my SMSs, my calls, my life is over XMPP. So I wanted to make sure it worked. I wanted Mumble. I have a role-playing game group that meets up. And hey, why not try? So I wanted to see if I could get Mumble working. And then I wanted something to play media. For me, media means podcasts and music. Audiobooks and TV shows are obviously a thing. I did not even try to like figure out descriptive video or whatever to watch a TV show, or just watch a TV show that I like with not knowing what it looks like. But I was hoping, but we will talk about what happened. So basically, every choice I made was based on my screen reader choice. You've probably heard of Orca, right? You might have heard of Fenrir. It's pretty popular in the Linux space. It's a Python-based screen reader. And I've heard some rumblings about a thing called Yet Another Screen Reader, which is, you knew there was a screen reader called Yasser, but you didn't know it was Yasser, probably. And so I first tried Fenrir. I don't use GNOME, and so I wanted to try something that was not GNOME specific. So hey, it's in pip, and it supports BSD in like the top of its README file, and I was like, oh, great. I ran it for 2 hours, and then the pip process crashed. I'm pretty sure there was a wheel somewhere. So I tried pipx, and I let pipx run all night, and it installed. And then the screen reader crashed. I started to try to pull apart the wheels and figure out everything. I managed to break a lot of my Python. I paved the entire OS, and I started again. I could not get Fenrir working on OpenBSD. I bet if someone goes out, figures out what wheel it is, and compiles that wheel for OpenBSD, it will work fine. I did not do that. I do not even know where to start. I am not a Python guy in any stretch of the imagination. So I tried Orca. Hey, Orca's in packages. So I just started throw Orca on the computer, and it started reading every keystroke I made, which was nice. Reading my keystrokes was useful, but it did not help me. I tried to get it to read Windows. It did not work at all. I could never get it to read a text drawn in a window. It just read my keystrokes. I tried to get it to run in a TTY. It would refuse to even run in a TTY. It was like, oh, X isn't here. I can't read keystrokes without X. It's fine. I tried to install GNOME. I was like, hey, I will give up. I will install GNOME, and it will just work. Once I installed GNOME, audio never worked on that computer again. I think it was Pipewire's fault. I have no idea. That computer never made a sound. It would not play music. It would not speak with Orca. It would not do anything. I don't know. I'm sure somebody has run GNOME on OpenBSD successfully here. I hope so. So it's probably my computer's fault, probably my hardware's fault. I had to pave the OS and start again. That's 2 for 2, which is not a good track record. So I'm going to talk about Yasser, and I want to draw your attention to Tim Chase. Tim Chase wrote a blog on this topic, and this literally saved me. This saved this entire project and this entire talk. In 2019, he wrote a blog post on Yasser saying, I set up a terminal screen reader on OpenBSD, and I installed Yasser. I just went to their GitHub and git clone and make, and it all worked. So I was like, hey, great. So I tried it. Since that blog post is written, they switched to Meson and made a bunch of changes in 2020, 2021 time period. I don't know what happened. I don't know anything about Meson. I don't even know what Meson is beyond a build system. I am not a software developer. I massaged the Meson. I read error messages. I paid attention, and I got a build to work. Every time I started that build, it would segfault. I have no idea what I'm doing. OK, but it's fine. I know when it worked. I know that Tim Chase got it working 7 years ago. So I checked out the git commit made before the blog post was written. And then I typed make, and it worked. If I hit Control-A to go back to the beginning of my line, my screen reader would crash. Not great. If I hit Control-R to search my terminal, my screen reader would crash. Not great. But you know what? It worked. I had a quick exit button for my screen reader, I think is what I meant to say. So Yasser worked. It would read me characters on my terminals. Would not read me my windows, would read me my terminals. So everything's got to be TTY. Everything's got to be terminals. I'm not even going to start X. It was great. Problem. When I tried to log in to a session, what's the feedback that you successfully logged in to your session in a TTY? Nothing. Prompt. So I just put in my .profile, echo login success pipe flight. And so I'd start my computer, type my username, type my password, and it would go login success. And it worked. And then I just typed screen reader, which was my Yasser wrapper that like set all my stuff up, and it worked perfectly. It was probably not the world's best solution, but it worked real well. I actually had to turn it off on the train here. I've been using it ever since. It also meant that every time I would open a terminal emulator, it would go login success for me because it was in my profile. This was not a great solution, but it worked real well, shockingly. OK, now I need to take a step back. I need to take a breather. And I need to try to send an email and look at a website. EdBrowse. Has any of you heard of EdBrowse? Seriously. Steven's heard of EdBrowse from me. EdBrowse is so cool. There is a person who is blind. They are constantly using this tool. It is perfect for a very specific kind of user. If you are the kind of person who really wants to use their copy of EdMastery that they bought from Michael Lucas a couple of years back, and also would love to try a browser, it is that. It is a browser using Ed. You like EdBrowse web page, and then it just shows like how many lines on the web page, and you type like 1, P, enter, and it'll print the web page, and you can be like 1, 22, P, enter, and it'll print the first 22 lines of your web page, J to get the next page, etc. EdBrowse is amazing. It does what you need. Now, you might think that it might not be full featured enough. It has a JavaScript engine. It has a mail client. I think it can do PDF rendering. I don't know how to trigger it. I've never tried, but I've read in its documentation. But it only uses text, and it just takes the stuff that you've done, shoves it into a text buffer, and treats it as if it's Ed. I swear to you, EdBrowse is the best piece of software I have ever used. It is obviously a passion project by one person who is using it every single day to run their life, and it is amazing, and you 100% should try it. Okay, that's mail and browser out of the way. EdBrowse just did both for basically free. So, like I said, I wanted to play role-playing games on Mumble. I love Mumble, so I started looking around for a console Mumble client. I found something called MumRS, which is awesome. And it says in its header, supports BSD. And so I tried to run it and it said, target target OpenBSD not found. Okay, cool. Open up the makefile, and there's a bunch of ifdefs and everything. Oh, ifdef FreeBSD, ifdef FreeBSD, ifdef FreeBSD. Okay, I understand. That's fine, I get it. So s/FreeBSD/OpenBSD, enter. Tried to get it to run. It connected to the Mumble server. It didn't build super well. There was a lot of faults. It connected, but the sound difference, like the sound differences between OpenBSD and FreeBSD were too much for it. It could never play sound. I decided to try to think about sound libraries and if I could fix anything. This was like April 25th or something. I did not have time. The screen reader journey took me to the beginning of April, to be clear, so I did not have time. I really wish I had, but it never worked out. I just gave up on Mumble. So I already have said my entire life is through XMPP. I love XMPP. It's how I talk to my wife. It's how I talk to my kids. I really wanted this part to work because I really wanted to use XMPP. I tried. I know about Finch and Profanity, but they're both Curses clients. And at this point, I believe Curses is cursed. Unfortunately, I'll talk about that later. JJ and SJ. Has anyone heard of JJ and SJ? Anyone heard of II? II is an IRC client. JJ is the like Jabber version of that IRC client. I got them to work, but I couldn't get them to send stanzas. I got Go Send XMPP, a Go client, to connect to a group chat, and I could see the user in the group chat, but I could see no stanzas coming from it when I tried to send a message, and I couldn't receive any messages. I was really hoping. I completely ran out of time to get anything to work, but nothing worked. I even bugged this guy a little bit, and I couldn't get it to work. I would love for those things to work. I don't know why they're not working on BSD. I will probably put more time into these, but that's OK. This is, I think, the most important. I was going to be lying in bed in pain a lot of this time, so I just really wanted to listen to music, and I wanted to be able to do so without seeing things. My home media server is Jellyfin. There's a project called JF2E. If you've never used JF2E, you should use JF2E. It is a console interface to Jellyfin. I love it. It lets me just view my libraries. It does have a flaw, which is it pushes everything through mPlayer. mPlayer loves to display album art. And it makes a window that spawns as the window with focus containing album art with no feedback or warning or easy toggling, especially when wrapped in JF2E. So I just got album art written over my screen. So I was like, OK, again, I'm never going to use X. So I go to my TTY, and I try JF2E, and it displays the album art in the frame buffer, which is clever. It's hard to do, but it was not a good idea. Now I can't even like navigate. It's eating my keystrokes. It's not letting me use my screen reader. My entire screen reader is broken. I figured out if I ran tmux inside Yasser, ran JF2E inside tmux, I could then have it eat the entire tmux session, and then I just like open a new window and hope. Like a new tmux pane and hope. And that worked, actually. The album art just kind of stayed in its tmux pane. It was not good, though. Like, please don't draw things on my screen that I didn't ask for. But that's just kind of mPlayer. Podcasts. My cited flow for podcasts is I have a VM with running the console tool CastGet, which every night at midnight downloads all of my podcasts. Or sorry, no. Every night at midnight, it checks for any podcasts in the MPD playlist. If there are podcasts that are not in the MPD playlist, it deletes them. It then downloads all of my podcasts, enumerates the podcasts that are not in the MPD playlist, and adds them to the end of the MPD playlist. I then play and pause the MPD stream, and my MPD output is an internet radio station. I then listen to the internet radio station playing and pausing MPD. So I use IceCast, CVLC, and MPC and CastGet. That is my cited flow for podcasts. This actually worked perfectly when I'm using, when I'm blind, because there was no human intervention in most things. I had no problems. This is why this worked for me. OK, I wanted to play an interactive fiction game. So these days, the new hotness in interactive fiction is Twine. It's a nice JavaScript library. You write your script, and it makes it into a nice JavaScript object. You run it in your browser. Did you know that when you use Twine and you render that JavaScript, it dumps to the console the entire Twine script, and then uses JavaScript display hacks to only show the part you want to see? Because that's not good. So EdBrowse would just dump the entire Twine script onto the screen. It did not help me. I could never figure out how to play Twine in EdBrowse. That's OK. Frotz exists. We all have tried Frotz, right? Frotz will just play like old zglob files from back in the day. They were great. I got through 2 games, both of them a little bit more modern than the ancient ones. I'm also a Inform 7 partisan. If you have never written code in Inform 7, I think you owe yourself time to do it. I last wrote Inform 7 with an 8-year-old. We worked together. We wrote a game together. It was very simple. It took me about 2 hours to learn Inform 7. I really think you should do it. And then you can play it in Frotz. Frotz works great. Do not draw ASCII art in your text adventures, please. I don't know if you've ever started a text adventure and it goes $, star, 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 $, star, 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 and you're just like, I don't know what's happening. What is even this screen? I don't know where I am. There was a lot of early text adventures that would do that, because obviously they were trying to get graphics and stuff, and graphical adventures were kind of a thing. Sierra started with drawing single screens, then went to King's Quest, but yeah. For the most part, Frotz was amazing. Cool, so I've gone through my list of things. I've done everything. And I just want to talk about some more generic things about screen readers and other stuff. Output buffers are incredibly important when you're managing screen readers. The way that you output text and the way that you buffer text really matter. I don't know if you've ever tried to SFTP a file, and it goes like temporary blindness.pdf =, 2%, temporary blindness.pdf =, 3%, and then does that every second. Every time I would want a prompt to work, I called my laptop RAR. My 4-year-old at the time named it. And so I hit enter, and it would go RAR dollar. And it was how I knew I was at a prompt that worked, which worked out, but also was very weird. Package add, I could never get it to stop. I probably could have gotten it to stop reporting things if I was sighted, but I couldn't easily if I was blind. Because I don't know if you've ever tried to use Apropos with a screen reader, but Apropos will often give you dozens of man pages completely unbuffered. So I'm sending Apropos output to EdBrowse and then trying to page through it line by line and listen to the beginning, but the first word is the only word you need, and then it starts reading a description to you that you don't have the ability to process very easily. It is very overwhelming. If I was good with a screen reader, this might not be a problem. Obviously, I'm not good with a screen reader. I used it for 2 days. Also, Tmux's bottom bar was really funny because it would tell me the time, but only the seconds. Every few seconds, it would update the seconds in Tmux, and my screen reader would read me the seconds change. It took me forever to figure out why it would say random numbers. Screen readers and Unicode. Have you ever seen a post on social media that's like, don't post in mathematical text, it breaks screen readers? And you're like, well, why doesn't the screen reader just read the mathematical text as text? Like, it can, right? The answer is, you really need to know what kind of letter you wrote. And I didn't think about that very much before I used a screen reader. But so much of the time, I would have caps lock on, and I'd type something and be like, error, and I'd type it again, and I hit backspace, and be like, capital C. I'd be like, oh, that's what happened, or something like that. There are so many times where there's semantic value to the area of Unicode you're using. So the few times where it isn't, a screen reader would be broken. Like, a screen reader should not make that decision for me, because the screen reader cannot make that decision, if that makes sense. This was really enlightening, because I've always wondered why screen readers just don't go, well, like, these texts all are the same, I'll just use them as the same thing. But if you're using weird parts of Unicode, you usually want to be, and that is a problem. I don't know, I have no idea about even how to solve this problem. Okay, this USB dongle, I have a 2012 MacBook Air, and it has a crappy USB dongle, and it would not work with my parents' Wi-Fi. I lived with my parents during the time. I did not want a 5-year-old jumping in my face while I had scarred eyeballs. So I lived with my parents. My kids visited me. So I had to use ifconfig a whole lot to try to like configure Wi-Fi. But I could not figure out where ERTWN0 was in edbrowse very well, because I've been piping ifconfig to edbrowse in order to read this, and it was really hard to figure out where the different separations of the different things are. I don't know how to fix that. Indentation is currently our method, and I'd love to have better understanding. I don't know if that's an accessibility problem in that, like, I don't know how to use screen readers, or I don't know how to use edbrowse, or I don't know if it's an accessibility problem in that, like, we should have like hints somehow. I don't know. I'm just raising it as a thing I noticed. ifconfig, apropos obviously, but just like so many tools would dump a lot of text to the screen. PS was awful, even on a very simple machine. And as part of that, I don't know if you've ever heard screen readers work, but they're incredibly quick. They read so quick, and I've always been like, I can't understand this. What is going on? Why is it reading so quickly? And it turns out that the answer is because they have to. If you've ever tried to sit down and you're like, okay, I just need to figure out what's in this ifconfig or whatever, and the screen reader starts reading the entire ifconfig output to you, line by line, every flag, everything. It takes forever. So I was like, why is my screen reader so slow within like 2 hours of using one seriously? So yeah, they gotta be that fast. But you also just can't skim text in any meaningful way. A screen reader can read a little bit slower than I can read, but infinitely slower than I can skim. And so when you're using a screen reader, skimming text is not an option. So having better tooling to skim text, obviously less edbrowse, other things like that will let you just like page through text very quickly and engage with things. I could never do it with a screen reader. I'm not very good with a screen reader. I was blind for 2 days. This is a talk about being blind for 2 days, not a talk for being blind for life. But at the same time, I think it's important to think about those kinds of things. I don't know what the solution looks like, but I think it's something that we should be thinking about when we are designing software. And then in general, the screen reader is my window manager, in my opinion, when I'm running things. Like I said at the top, the screen reader made every UI choice I made. Like every UI choice I made was based on my screen reader. As such, I want to make sure that we understand that like if we are mandating screen readers, we're making decisions about screen readers for people. It's the same as saying, oh no, you can't use our system without KDE. Why would that work? Or you can't use it without DWM. You can only use Sway. That would be really annoying. So mandating screen readers is really annoying. Choice in the ecosystem is really important. And thinking of them as first-class consumers is, I think, really important. And so I'm going to request everybody try to use EdBrowse a couple of times in your life. Just try viewing the web in EdBrowse. See how Mastodon completely breaks. Friendica completely breaks in a different way. Twine completely garbages on a site. Your website might break things, but your website might be awesome. And just test. Try stuff. And try going blind for a few days. I think it was actually really enlightening. You can use a blindfold. I don't recommend getting your eyes scraped off. But yeah. So I think I'm at time, right? It's about 5, right?
About 10 minutes.
Oh, I got about 10? Oh, that's more than I wanted. I went too fast, but I'm going to answer questions, because that's all the slides I have. I spoke too quickly. I should have talked more about my eyes getting scraped off. Sorry. Gallows humor. Yeah.
In the intervening time, have you tried using screen readers on platforms beside OpenBSD, like VoiceOver on macOS or JAWS or NVDA on Windows?
I've used VoiceOver on macOS.
Can you repeat the question?
Oh, sorry. The question is, have I used screen readers on systems that aren't OpenBSD? In the intervening time. Now, in the intervening time, I have not used basically any screen readers. I've had an incredibly stressful year. But previously, I have tried using Orca on Linux. I've tried using VoiceOver on macOS. I think VoiceOver on macOS was my escape hatch. It was the one that I trusted the most. I've heard that a lot from a lot of people, that it's the easiest one to get onto. I know a lot of screen reader users use macOS. I know there are some good Windows ones, and there's a strong Windows screen reader community, but there's also a very strong macOS community, and I've used it, and it worked really well. So yeah. And things like being able to click on text and then just have it get read was so nice. Yeah, go.
So you talked a lot about your experiences with output in a temporary blindness situation.
Yeah.
Could you speak a bit to input? Things like, did you consider things like speech to text, or you're still typing blind?
Did I consider things like speech to text or other input methods? I don't look at my keyboard. My keyboard doesn't even have letters on it, so I just took my keyboard and typed on my keyboard. I didn't really think about it. Obviously, I also spent the entire time in a TTY, so I didn't use a mouse at all. I just used a keyboard. I did not think about that as a problem. I've used speech to text in the past, but not in many years. I don't think I could speak to it meaningfully. Sorry, yeah, go. Is it pronounced as Git or JIT? I have always pronounced it Git. I believe it is a reference to the English insult Git.
How does the screen reader pronounce GIF?
Oh, the screen reader. Sorry, how does the screen reader pronounce Git or JIT? GIF. Oh, GIF. Sorry, how did the screen reader pronounce GIF? I do not know. If you talk to me afterwards, I have a laptop with a functional screen reader, and we can go try. It currently does not say login success, though, so I had to change that for the train. But we can figure that out in a second. Sorry, I saw another hand, I thought. Oh, yes. Yeah.
How are your eyes now?
So because my corneas are hardening and regrowing into the right shape, for a couple of months, my prescription was changing every couple of hours. So I'd be looking at a screen and have to refocus my eyes intentionally. And now I'm still not allowed to wear glasses because I couldn't get a useful prescription. My prescription meeting to get my glasses is Monday. I'm actually can see better than I used to be able to, which is really nice. That was not, I didn't know that was going to be an outcome, but I'm really happy. And second question?
Second question was, so the power budget for most laptops primarily goes to the screen.
Yeah.
Is there enough utility in using a screen reader, do you think, to actually do that by choice?
Doing it by choice. I think if you got really good at it, you could do it really well. Oh, sorry. Power budget in laptops mostly goes to screen. Would it be reasonable to use a screen reader just for no reason, other than power or whatever? Probably. I think you could do it. I think it would be very fun to try. I definitely have used EdBrowse on purpose before this project, but yeah, you should definitely try it. I don't know if you'll do super well, but I think it would be fun. I think it would also be really good because even if you do it for like a week or something, like I say, try going blind for a few days. I think it'd be awesome. It says GIF. Yes?
I just had an idea for, with AI being what it is, you could probably make a device that you plug an HDMI, type it into some sort of like, hey AI, watch this one. And if I have questions about what I'm seeing, I talk to you about it. And it just like talk to you about it.
Could I make a descriptive video over HDMI device or an LLM-based describe HDMI stream device, basically? You probably could. The HDMI people would probably go after you for money. Unless you run it on Windows or Mac. But the HDMI people would go after you for money, is what I think.
Or build it as like a glasses app.
I think that's a thing that exists. I think there are like descriptive video headgears.
Yeah, just to elaborate on that.
Yeah?
Phones do actually support like describing things seen on camera.
Yeah. Comment was that a lot of phones will have, look at your, like, here's a picture, can you describe it to me just via the camera immediately? And I think that's a real thing. I mean, I've definitely heard of that. I did not try that. Anything else? Oh, yes.
For doing lots of terminal output, did you end up finding a better situation than EdBrowse? Like, were you able to use like a fuzzy finder to kind of narrow the output so that you didn't have to get like walls of text read to you?
Did I end up using a fuzzy finder to manage walls of text read out to me? One of the problems was I didn't realize how bad it was going to be before I was blind. So I didn't really prepare for it as a problem, and then I realized how objectively terrible it was. And did EdBrowse like is ed, so I can like do like greps and things. So that side of it, I could mostly use it where necessary, just using it as a pager. And obviously, I could have used less, or I could have used whatever pager you love. I never ended up using a tool beyond that. I definitely think there is space for that. I just don't know enough of the space because typically my wife has walked in on me just like catting a log and letting it scroll past my screen for 40 minutes and go, oh, hey, there's a minor change in the scroll. And she's just like, how did you do that? So that's kind of how I do things already. So I don't have those in my lexicon, but yeah. Yes?
Was there a key to have the screen reader stop reading so that if you were getting a wall of text you didn't want, you could tell it to buzz off and let you do something else?
Was there a key to let the screen reader stop reading? Actually, oh, that's a thing I forgot. So that Tmux, it would when it got a new input, it would stop reading the old input and start reading the new input. So I'd be trying to read apropos, and then it would go 02. And I'd be like, oh no, what happened? So there was that, but I could also just like hit enter and just like get it to go $. So it would end my like session for me. So there is that, like it did work that way. Oh, yes.
Any challenges if you need to use a website that has a reCAPTCHA or something like that?
Oh, reCAPTCHA. Were there any challenges to using reCAPTCHA or other similar tools? I never got hit by one. This was March, right before the big wave of Cloudflare CAPTCHAs. So I never ended up getting hit by one. I also mostly stayed on websites I controlled, like my Fediverse account, things like that. But yeah, one of the advantages of EdBrowse is it does have a JavaScript engine, so it will pass things like Anubis, usually. Well, thank you all for listening to me talk about this topic.
Double check. Hello? Double check. Hello?
So, hello and welcome to our talk. This is the highly involved version of our talk last year. So we will present today our involving chaos education and evolved it in a distributed FreeBSD native platform or framework. My name is Andreas Kirchner, that is Benedikt Reuschling. I think that's the name here in the community. The whole system is based on Bastille, OpenZFS, distributed Unix education, and of course FreeBSD and jails. And also it is based on FreeBSD 15. And I would like to thank first the community to invite us again after our talk last year. That gives us a sign that the talk was not so bad.
We must have done something right there.
Yes.
Yeah.
And now I will hand over to Benedikt.
Yeah, so for those people who weren't here last year or those people who were and don't remember everything yet or anymore, I just want to recap a little bit what we did. Not too long, not too much, but just to get everyone on the same page. So I'm teaching in the University of Applied Sciences Darmstadt, and for the longest time in a Unix course, for the longest time I was a bit frustrated. I hand out an assignment, the same for everyone, and students do it more or less all right, and then yeah, I'm kind of frustrated by the end result in the exam because they seem not to have learned much or don't recall many things. And in recent years, they also the addition of AI made it even worse because the assignment has already been solved multiple times, and students just pass around the solutions. They don't care about the actual learning effects anymore. And so I thought, how could we improve this a little bit? So the classroom is a bit looking like this, a bit of chaos, but I try to give a Unix course, not a FreeBSD or Linux specific course, but Unix in general, even though mainly the labs are based on FreeBSD. And let's look at the next slide.
Yes.
Where
so Benedikt and contact me and say, okay, do you have an idea to make my work easier? And yes, I must do a master thesis, so yes, I decided to help him.
Back then it was just a rough idea. Yeah, we could do something like this, and why don't we try that? And so the concept that you came up in the thesis was basically this jail-based system that would inject errors into the students' systems.
Yes.
And then they have to solve the error, find it first, and then come up with a solution.
So the talk is based on the problem, then why FreeBSD jails, our original architecture from the last year, then the real problems we encountered during that POC phase and the testing phase last year, then how we evolutioned it into a distributed framework, then our new training node storage lifecycle management, runtime tracking redesign. I talked last year about this big problem with the time scheduling, and then we followed by a deep dive. Also, monitoring stack, completely new designed, a bootstrap automation to use it on every FreeBSD system running FreeBSD 15, a live demo, what we have learned from this phase, and a conclusion on our question phase. So.
Yeah. So this is a little recap of the original background problem from last time. So again, the background, as I mentioned already, I'm a lecturer and I want to have the students a more realistic working environment because they will certainly encounter certain problems later in their work life as well. So I want to prepare them as soon as possible with these problem-solving skills while having a low-level setup stack so that I don't have to spend too many hours just preparing a single lab. And the difficulty should also range between easy to not frustrate students, but also very difficult for the more advanced students. And so I thought, why don't we create a concept like each student get a little working environment, they can get root access in that environment, aka a jail, and in those jails we can from the outside inject certain errors, files are missing or permissions are wrong or something, and then the students need to identify the problem, solve that problem, and the system would then automatically check whether each student has solved this problem, and a high score list would then be presented for the fastest students. They get higher points. And the Chaos Monkey approach is basically the concept from what Netflix invented that a system gets changed randomly and people need to fix it, and that way they learn more about the system and make it more resilient. And it doesn't mean that each student get the same error injected, so there's also not much copying of solutions possible. And what we found in the original evaluation, so he created a prototype during his master's thesis, and what we found while playing this with students, that students were engaged, they were also seeing much better problem-solving skills, and we also find that they were engaged more in the labs and liked these kinds of scenarios.
The information about this you can rewatch in the recording from last year.
So yeah, and even we thought, okay, with the advent of AI, would this concept be completely not useful anymore? Or why don't we create two groups? One group of students were not allowed to use AI and the other students were. And then we figured out, okay, how quickly did the students solve it? The ones with AI, are they a bit more advantaged with that? Or is it more of a hindrance because they have to type their prompts? And we figured out that our system is quite resilient against AI use. And the students are also more motivated finding these solutions and getting a bit more practical experience rather than a academic example, which is not so realistic in the real world.
So we are now why we used FreeBSD jails. So there are many tools on the market we could use: Docker, virtual machines, or jails. Why not Docker? Because Docker abstracts so many levels of networking, system things, real file system behaviors that we would like to teach in our concept. So it was not a perfect tool for us. Then why not using free virtual machines? That would be possible, but the overhead was so much and we had need so much performance in our system. It was not cost efficient. That is why we use FreeBSD jails that we could teach everything we would like to teach. And of course, it's lightweight and super fast and don't need so much CPU workload or capacity.
Resources.
Yes. Then for orchestrate the FreeBSD jails, we used the Bastille BSD in a really early version. I found during that phase many bugs. I reported them to Sven. We fixed that bug, so now we could use the whole capacity of Bastille. We used Bastille create first, and then we only used Bastille clone. It's much faster than since last year to create every jail from the scratch. Clone, I think it needs 1 or 2 seconds to clone a whole jail. It was so fast. Then we used OpenZFS for integration as snapshots, because if students make mistakes, we need a quick snapshot feature. And then we also implemented self-service snapshots, but we come later to that.
Yeah. So this is just a repetition of the original architecture from last year. So that you can compare it with our new architectures that Andreas will present in a minute. So the original idea or the prototype was using SSH logins to figure out, oh, does this jail has the solution yet? No, it doesn't. Okay, it goes to the next jail. Does it have the solution? Oh, yes, it does. Okay, then report back the result. But this took a while to set up properly, and it's kind of having an overhead because students might have solved the solution already, but next time the jail would come around, it would take a couple of minutes before that result was collected, and that would skew up the high score list, and students weren't as accurately monitored or measured as they should have. So we have for a web server jail that's basically just presenting the high score list for everyone. So during the class, students would see the high score list and whether someone else has already solved the scenario. And the controller system was basically the central component, which was also quite loaded and had a lot of operations to do. And then there were end students jails, like for a classroom like this, 16 students or so, each one would get their individual jail, and that would also be monitored by the monitor jail. And we can, as the conductors of this scenario, we would look at, oh, is this jail overloaded, or is it creating a high CPU load or something, so we can still interfere as the lecturers. And then the students would basically get an SSH key, log into the individual node, and start working on their scenarios.
And keep in your mind, last year I said the whole logic is based in the controller system. And for gathering the information from the student jail, the controller connects via SSH, gathering the information via a script, and write it back into the controller system. So it was monolithic written and was quite difficult to improve that. But keep in your mind this graphic. In a couple of slides, we will show the evolutioned version, so you will see what I mean.
And it was a prototype. We were actually quite happy that it worked, but we have a newer version now.
So real problems we encountered during that phase. As I said, you had a snapshot chaos. Students required if I could change my username, then could I install my own programs? Could I then make a snapshot? So that's the initial snapshot for the whole course or not? And Benedict was only doing snapshot creations all the times. Then we have a runtime tracking problem. Maybe you remembered last year it worked not so well in the presentation on in Asia. I fixed that now. It was based on last and username. There was mixed up with usernames, and the last command was executed by a script. So you must connect to the system, execute last, and then you write the results back. That is why plus inaccurate runtime values, because you have delay between the connection and writebacks, and that was not so good. Then we have infrastructure problems. We have PF edge cases, but still network works. CLR-LF problems, because, as you mentioned, I worked on Windows. Now I changed to Mac, so that was a big problem because I wrote the scripts on Windows and I have CLR-LF deployment problems. We have bootstrap race conditions and server startup order issues, because if you start the first service, then you need the next service, and depend on the first service, it will not work. Maybe you know it on distributed system. Then problems we encountered. PF, problems on Apple Silicon ARM. Anti-spoof for external interfaces, INET doesn't work well. Also the scrub feature doesn't work well, so for this version I disabled it first. Maybe Peter has the better idea how to fix this. But yes, for the first, we disabled this feature. Another big problem was the monolithic orchestration, because everything goes from the controller, and this was not possible to make it really distributed, and also workload issues. And of course, we would like to take red versus blue team scenarios, so you can run 2 different scenarios on the same time. It was not possible with the old architecture, and the POC evaluation showed that students has transparency problems. They would like to saw how the sum of the points are consistent together, yes, and would like to see where there are weaknesses and where should they improve their skills. That is why I first fixed, so now I come over the evolution into a distributed framework. That is why I first fixed the transparency problem. You could see there now the new high score list. You can see a clearly written instruction from the naming from the training nodes. We now changed also into training nodes instead of student nodes, so maybe you would not use it in your companies, and then it's easier to present it like training nodes. We have now 2 clusters for the testing. CE, chaos education 0, Charlie 02 for cluster 2. Then training node 03 or 04 in the clusterings. Then now you can click on each cluster, or each jail, and then you see the consumption from the scenarios. You see DNS manipulation, medium, successful or not, how many times you need it, if you get the bonus or not, you don't get the bonus. If ones who is interested into the bonus system, I also give an advice on our record from the last year. Then now, the new concept. That is why I said it's really complex now. Yes, you have a base CR host. Chaos Education host is a FreeBSD host machine. Then you have jails on it. Training node XY is Y, because you can 1 to N. It's limited, I think, under 100 nodes per each cluster. So if you have enough power, you can do this. I would not recommend this. Of course, we have our CE web. It's the web service. Our web service client now is the naming is also consistent. And of course, the clusterings. Clustering 1, clustering 2, and the monitoring jail who is health-checking every jails in the system, even the host system. Then the database problem, we come later to this. It's Benedict fault. Yes, what he will say. something about this. The students also read the high school listed as before. Jumps via SSH, jump hosting onto the host system, from the host system into the jails. Currently, the cluster controller is only software-based. It's not a real jail. It was performance things, but it's okay, it works. So then the training node has a CE client. The client is written on C++ and C, really hardware near, and that it's quick and fast. It's a hidden process on the systems. The CE client will do many things. I will come later to this. The CE client publishes via API on HTTP ports, and you can, the CE cluster, C0 cluster, will pull and reply this by HTTPS requests or HTTP. I've now worked on HTTPS requests. Then the cluster will write it into the hosts, and the host will also publish this via an export client via JSON API into the CE web with HTTPS push. Yes, the lecturer operates now the CE host, controls the CE host, select the scenario. The scenario selected will be published on the cluster, and the cluster will publish it, cluster controller, and the cluster controller will publish it on every training node into the cluster. So it's really complex now, but it works well. For the orchestration and all the code designs, we picked up Go. Last year we used Bash because of proof of concept, but Go is much faster, it's multi-threaded, it's easy to learn. Our design priorities, I mentioned execute this script command, it's now gone. We are now able to manage Bastille really fast, set up jails multi-threaded, pass and write via JSON files. And of course, the Go code is easy to understand and better for the contributors. Maybe they will join later after our talk. Then, while Go fits well, small static binaries, simple cross-compilation. It's, as I mentioned, fast and build. And of course, it is natively working on FreeBSD. Why not Rust? Because it's higher to learn. The benefit of this is not so big that I won't learn Rust. Won't learn Rust. And a more complex ownership model. So that is easy why we don't use Rust. If you want to use Rust, you can make contribution and we can reroute our whole code in Rust. So it's up to you. Our takeaway from this, as I said, because the framework needs to be operational, simple, portable, readable, and easy to extend. So, and now it's Benedict's time.
So, yeah, originally in the talk description, we were promising or saying something about a database where that would keep the scenarios that you can load the scenarios from, and also the high score list data would then be stored in the database so you can later review it. If you have a multiple day event like this, or over the semester, you can start from the first week, and then on the end, last week, we would have all these results or the scores the students achieved in the database. We took a little bit more time than we anticipated for setting up the whole controller scenario and the scenario synchronization. So we haven't had success yet, or haven't had time before coming here to finish the scenario database. So we kind of kept that out and try to implement this by EuroBSDCan. So it's not everything that we promised in the talk today in description, but I think the result matters to have something working, and then later, once that foundation is there, we can then attach the database fairly easily to it to have the scenario database in it.
Yes, and if we did this, then the database should store the scenarios completely and also the logs from the host, that you can every time come back to the host and are also be auditable if you use it in your companies.
So, yeah, sorry.
So,
but let's talk about the training node storage lifecycle management, aka snapshots. So what students typically want is they have a scenario, they don't know whether the solution they try will work, and then they would typically ask us, what if I do something wrong? What if I delete an important file or something breaks? Then they ask me, hey, can you make a snapshot? And I could do that, sure. I always do that for starting such a scenario. But the students during a scenario also wanted their own snapshots to have a certain state to fall back to. And now we can do that by letting the students create their own scenario with their own little naming scheme. And that keeps the instructor, aka me or us, out of the game of running around and, oh, you want a snapshot? Okay, let's create. Oh, another one wants a snapshot. Oh, okay, I create also another one. So if students can do that on their own whenever they need it, they are now capable of doing that. And I, as the instructor, can individually roll back the scenarios if a student can't connect anymore or something breaks, they lock themselves out. I can individually restore that particular jail without affecting the other students, so they can continue working. And we also have, when we switch scenarios, a snapshot lifecycle improvement. So in the past, in certain scenarios for the prototype, we still had certain edge cases where old scenario data was lying around or some old information was available that the students shouldn't see. So now we have this lifecycle management that wipes completely the old state away, and we don't have any old scoring data lying around, or some runtime caches are not there anymore. So everything's properly cleaned up.
Yes. And Bennett mentioned, in the first of scenarios, you get before the scenario, you get a pre-ID from the snapshot. And if the student wants to request it, he only must write in his bash or shell command line, chaos snapshot request, and then in brackets? No,
yep,
no.
Quotes.
In quotes, what you want to have as a message for the destructor, like before BSDCan 2076. And then it will resort at student requests from the where clustered from the CE, chaos education, cluster 01, training node 05, and then the timestamp on it.
And the naming scheme really helps us to understand when was this scenario and what scenario did we play, and from which student was this snapshot created.
Yes, and we will show this later in our dashboard in the live demo.
Yep.
Right. So now the runtime tracking redesign. As I said, the last year it was only based on an old approach on last who, for who the username you want to track by a script via SSH. It ran into really many problems by that. Then our new approach was runtime tracking directly in the CPP client. The next step was directly compute the scenario time into the CPP client, not in the cluster controller, and then publish the CPP client the time, and in a big JSON file where something written like scenarios running, time you got, user, cluster node ID, cluster node namings in a JSON file. So I only print here a little example cut out of this JSON. You see logging seconds. I was really fast in that try, 68 seconds. Then which scenario we executed, the timestamp, the JSON was written there. And you can access this via HTTPL, then node IP, and then AT and pull. That is the HTTP pull request. Now we come into a deep dive.
Yeah, so the deep dive is a little bit more geared towards how does this all work and in which order do these systems work. So first, we need to roll out the whole thing. If I start a new semester, I can't recall how I did it last time. Now I have a little setup routine that does it for me. And the provisioning is really quick because we are just cloning jails. And each student, no matter how many there will be, sometimes students come in late and register for the class, and then they go, can I also get a VM? Yeah, sure, you have another one. But if you have a class of 40 students, you don't want to manually create jails this way. So we have a provisioning system now, which is very fast. And it's also possible to do it in like another setting, like in a workshop or for a capture the flag event, for example. And I also can provide my own configuration to it. I can say, this time I want to give the students a couple files in their jails already and not a plain FreeBSD jail. We also have the integration of the monitoring agent, so I can right away see what the students are doing or if jails are running too much CPU or RAM. And we also have the automatic initial snapshot creation, so I don't have to take care of all of that when I start a scenario, because I want to focus on the teaching part and not doing a lot of technological or setup stuff to get the scenario running. And during the scenario, so I give students a certain amount of time to solve that, and the longer they take, the less points they get. And I can already track how far or how many students have already finished it. And for the students who are still struggling, I can still send them a couple messages and give them some hints. Hey, have you tried this before? Or look into the, a book and figure out what we talked about last week in the lecture because you didn't attend. And this is all done by this workflow.
So the next big core feature of this new architecture is the Chaos client. I try to explain it on one slide. It's not so easy because the Chaos client is so much powerful. At first, the Chaos client runs on every training node and runs there in the idle processing. After a scenario would be started, the Chaos clients track the time was before the user was logged in before and exclude this time from the scenario starting time. Then the scenario code is loaded into the client because I wrote the scenario check script into a temp file, loaded into the memory of the client. The client will execute this in C++, in binary code, execute this, and remove the evidence of the solution from the host, from the jail completely. So the only place where the solution of the scenario are stored is into the binaries of this code, of the client. Then the runtime state also, this client also observes if the client healthy, is the jail healthy, got the network informations of the jail, if the cluster is available, load the client configs from the cluster controller, logs every messages. You could publish these messages, it's not implemented, but you are able to publish these messages to the cluster controller. It's a notification service-based system, so last year I tried every minute or every 30 seconds if the solution is, if the student are done with the solution. This time it's so, you wrote into the solution script how files should be affected to find the solution. And even if these files would be edited, they would be notified because it's watching observer job on these files, will be notified to the client, and the client will start his work. So you don't lose so much power into the idle phase. Yes, and all the informations the client will calculate, stored, something like that, and is necessary for the controller will be published via JSON API. And so the client turns each training jail into observable self-reporting training node. And self-healing, of course. That is the API you got. You have a host name, you have cluster ID, you have scenario DNS manipulation, scenario is running. You have your scenario run ID, every scenario have really unique ID, as ID, and a status of the scenario, it's successful or not. If successful is true, the status could also be no scenario is running. So yeah, it's really double the feature, but yes. Then the logging sessions from the scenario, so it was, I think, the second try, and I was really tired, so I need 842 seconds for this, and the timestamp when I got this solution. The time is not the real time, so I think it was 3 a.m. in the morning. So yeah.
Late night coding.
Yes, late night coding. It's the best time to code, so yeah.
So how does this work when I start the class? So at first I pick a scenario that I want to torture the students with, and then I deploy this to all the nodes so that everyone has the same base setup. Then the students would start working on that, and I have a baseline. Like I would say, for me, this scenario to solve it would take maybe 5 minutes, and that's the baseline that I have set. Sometimes students are faster, sometimes students are taking a little longer. Then the scenario monitoring starts and brings up all these monitors to see in the dashboard what kind of load each individual jail has. And ideally, the students start solving the scenario, sometimes a bit faster, sometimes slower. And that causes an automatic scoring to start, which would then update the high score list and notify the system that the scenario is completed. And then there's two optional parts. We, as lecturers, can communicate with each jail and the student and say, have you tried this before? Or congratulations or something. They already get an automated congratulations message to notify them that they really have solved the scenario. And you can also, as I said, roll back individual scenario notes in case students really destroyed the jail and couldn't work with it anymore. So that's the whole run through. And so how is each scenario defined? What components do you need? We need a task description. This is displayed to the students like, for some reason the network is down, and can you try to identify where that happened? And then there's a template which would be deployed. So sometimes I would roll out certain files that are maybe incomplete, or I would manipulate existing system files. So these are the template parts. And then I need to also figure out, has the student solved this scenario? So we would have a validation script that would continually run on the jail and figure out, has it been solved yet? And the last part is the difficulty. So we currently have 3 difficulties: easy, medium, and difficult or hard. And depending on if I see a class is quite good, they solve the easy scenarios very well, and I could go one level higher in the difficulty. And that also involves is part of the scoring system. Harder scenarios give you more points, easier scenarios a little less, but it also shouldn't be frustrating to the students, right? So this is also part of the building blocks of a scenario. And we can write fairly easily these scenario definitions. You can probably think of a couple nasty things you can do to systems. And as long as your validation script figures, okay, has it solved this, then pretty much everyone could write their own scenarios without knowing too much about the base system in the background. And you can put supporting files in there, as I said, maybe a log file that's too large and the disk space goes down, or you want to deploy certain applications to it. That's also possible by the scenario description.
Yes, and for those who are interested in, the task description will be sent if you are not logged in by the message of the day, or if you're logged in by wall. It's an easy tool, and you can send the messages, but there's a little issue. You got the message twice. If someone of you has ideas how to fix that, please write me in it afterwards. So now, monitoring stack, the new monitoring stack. The old one, I think maybe you remember, was a manual Grafana data source setup because I didn't find the automated one. Then export occasionally available after restarts because the exporter, node exporter tool sometimes doesn't work if you start the processes into the Bastille file in the wrong order. Now this is fixed. And manual Prometheus targets configuration. So I must log into the first time into the system. I must configure the Grafana completely manually. Now, the fixed version, it's automatic. You only install, you execute your scripts, and then everything is there. I use as default for Grafana the node exporter default dashboard. It's 4206. It's the recommended one for Node Exporter and Prometheus to use it together with Grafana. And now it's completely automatic. So then you have one command deployment, automatic monitoring setup, cluster visibility is also given. You can select into the Grafana cluster, nodes, student nodes, or a system like monitoring or something like that. And it's a self-healing. So I report this to a log, and the log executes scripts. And if some process turns down, it will be completely automatically restarts. And in most of the cases, as you know, a reboot fixes all problems. Yes. So the self-healing monitoring infrastructure, our problems, testing, monitoring components. As I said, jail restarts, system reboots, bootstrap operations, service failures. Now the framework automatically validates node exporter, Prometheus, Grafana, and Chaos Web Export. That is one we set together into the Hacker Lounge on Tuesday.
Yeah, last minute changes.
So then automatic recovery, health checks, verify service availabilities. So service node exporter will be restarted, service Prometheus will be restarted, or service Grafana will be restarted in case of errors. Then benefits we got reduced instructor workload because if something goes wrong, Benedict don't need to log into the system and fix the system manually. We have now increased platform reliability, faster recoveries because automatically, and an improved monitoring accuracy during the training sessions. So that is the new build. You don't see any new changes, but maybe in the top raw you saw Chaos training nodes and then the IP from one training node. And in the Chaos training nodes, I could select also the web monitoring or something like that.
Yeah, so the bootstrap automation is, again, my little install script at the beginning of the semester to roll out the whole stack and don't have to worry about individual nodes, setup, and special things. So what it starts with, I needed to automate all of this because the more components you have, the more difficult it is to start them in the right order, and maybe I forgot to install a package or something. So I want to have an install system that runs all these systems from beginning to end, and then I know that a certain state has been reached that this scenario can be started, and in case if during the semester I need to tear down the system again, I can restart it with the same bootstrap. I just basically run the bootstrap shell script, which basically runs all these installed scripts. Then the CTL configure, and that makes some changes depending on my scenarios, and then installing it to all these jails that are part of my class this semester. And yeah, then here are some challenges that we learned during the automation phase. So I thought, okay, automation, how hard could it be? Once it's automated, it will run forever and have no problems. But as we said, we found out that the certain line that we showed earlier behaved differently on the Apple Silicon ARMs and x86 systems. So we originally had a central server system, but the testing was done on our Macs here, and for some reason, this line in the pfconf caused the system to not work anymore. And once we commented this out, it suddenly worked for some reason. And that's what we have to figure out why that is. The loopback networking sometimes required a careful handling, because if you don't do it properly, then the old connection is still there, or the interface is still there. It would try to connect to the old one instead of the new one. So that caused a couple of headaches. And the interface discovery was a bit unreliable in the original client, and we tried to make this a bit more reliable so that we know we always work with that particular interface, so the students are not confused like which interface to connect to. And startup ordering became also critical, because if certain services were started before others, then the scenario wouldn't run, and we had really crazy debugging sessions like, why did this not happen? It used to work before. And sometimes also the Prometheus exporters failed after the jail restart, so we couldn't see what the students were doing in the jails or what the load would be. So that also needed a bit of debugging. But the improvements implemented are now creating automatic interfaces that are detected and properly assigned to the jails. Then we have the dynamic PF configuration. So I could say, oh, in this scenario, we're doing a network scenario that needs a bit more port access instead of blocking most of them. And that is based on the scenario, so the PF configuration is generated in the dynamic way. And the monitoring is automatically provisioned. So I, during a scenario, just sit there and watch the nodes, the CPU going up. And students are just trying to solve this and don't bother me with questions. Then we have the service health evaluation. So some systems would be restarted, or the jails kill the monitoring system, it would automatically respawn. And then the recovery and restart logic is also there.
So now
live demo.
Yeah, quick one, because
we need to hurry up. Okay, so I explain a little bit what we're doing, and Andreas will run the demo. So we have two windows. The one is for the instructor, and one is a student. Hopefully you can read that, big enough. And so this is the student logging in. They get
instructor.
Their proficient.
Instructor.
Oh, the instructor, sorry. The instructor is at the top and the student is at the bottom. And so the instructor figures, okay, what kind of scenario do we want to run today? Again, this could also be a penetration testing or a training scenario in a company, so it doesn't limit yourself to be in a university environment. And so we figure, okay, the system is already installed and rolled out. and we must check now what kind of.
Can you slide this over like just a teeny bit? We're cutting out.
Oh, we have some cutoff at the corner. Okay. Yeah. Thanks for letting us know, because otherwise people don't see too much. So, students get their logins, and we find out that the scenarios that I would be like, I think the class is ready for this kind of scenario, and then collect the information that I want and figure out, oh, here's me again.
Yes. So
That
now
often happens. So,
I will run a scenario.
okay, let's run a scenario. Yeah, you've seen it before, right? Then we figure out which cluster this should run on. Let's run the first one, and so the initialization starts. And now the students are getting their scenario as a wall message, and that's the indication for the students to start working on solving the scenario. And so maybe you know the solution already. So the students figure, it must be something about the networking, so maybe they try pinging something or checking their network configuration. And up there in the professor's view or the trainer's view, you don't see much at the moment, but in that time you could look at the Grafana dashboards and see if something is out of the ordinary. Yeah, oh dear, the name server is wrong. What did I do there? Okay, so the student figures this out, and then they get this broadcast message. Remember last year it took a minute before this message appears because the check script took a minute, and now we have immediate.
First scenario, complete 5 scenarios.
Yeah, so that we get a bit more extra.
Now you can click on it.
Yeah, and then I can see, oh, in which scenario did I get points or lose points? And then students could go back and say, maybe I need to study a bit more for this particular scenario.
And due to the time, I was really quick, so you saw 77 seconds.
Good one, yeah. That resolves in a lot of points, yeah.
Maybe we should now show other features, like you could request it. How's request? I don't know the name. I show a snapshot. Our live dashboard. You could select now the scenario you run. Then you see the time. It's now from the scenarios running on cluster 1, 17 seconds. And this was no snapshot requested if I now request snapshot.
And the other ones have not solved the scenario yet. So that's why this is success false. So let's create a snapshot just in case I break something.
I don't know the naming now.
Yeah, test.
No, it's not the right naming. Which slide was it?
It's in the slides.
Yeah, it's in the slides, so.
You need to pass the ID to it.
No, I
switched around, yeah. We can create an alias for that so that we could both.
Yes, you could create an alias for that.
I should make notes. There we go.
So, and now you could refresh there, and there is your snapshot. Yeah, created. And now Benedict could roll back the system by the snapshot ID.
Yeah.
And
maybe
of
a student
course,
has created a different scenario, all trying to solve another scenario, and that would I like, and then copy this as a new
via
scenario
the snapshot management. But I think we run out of time, so
yeah. Let's continue with the presentation.
Yes, let's continue with the presentation.
We have a bit of time into the lunch hour.
We stopped in this slide.
There we go.
So, what we learned. Our teaching concept was practical, hands-on learning increase engagement due to our feedback. Students preferred solving real problems over worksheets. And competitive scoring encouraged participants. The students was really eager to learn more about the system and motivated to do more of that stuff, and it was really positive feedback from the students. Then, our new technical architecture. FreeBSD jails scale extremely well. So I run on my one rack, actually, I think 8 jails, and the performance is quite well, so yeah, it's perfect. Then ZFS snapshot automatically simplified recovery operations because you saw it. I only did one command and got my snapshot and could roll back the whole system, and it's really fast. And our monitoring become essential as the platform group because you can't do it by yourself. You need a monitoring tool for this. And also, if the students mention at night, can't do my scenario, yeah, it was not due to our system, it's due because you don't want to work.
Yeah, the more complex, the more components it has, the more the need for creating an automation for it and roll it out consistently. And the runtime tracking is now much better than in the original prototype. And even though it's a bit more complex, we can still roll it out in a manner that's doable, and the students don't get too much excitement about it. We had a couple of things with PF behaving certain ways, which we
6 years, hundreds of millions of snapshots, 0 package dependencies. Right now, we're all feeling the pain on the hardware side. Who the heck is eating all of our drives? And what are we going to do about it? A huge chunk of the forward drive inventory is going to AI. Frontier open weight models are already 600 to 800 gigabytes. So here's a little math. 3 fine-tuned variants of the same model used to mean 3 full copies. With conventional workflows, that's triple the storage cost. Or it's 1 model plus deltas. That's the world ZFS and Zelta are built for. Let's get the most out of our deltas. I'm Daniel Bell. Here are a few things about me. But most importantly, I've been rocking BSDs since the 90s. I've been doing infrastructure in regulated environments for a long time, the kind of places where bad backup isn't just data loss, it's a regulatory event. I wrote Zelta because I needed a replication tool for my FreeBSD private cloud that matched how I think about backups and iteration. What started as a backup tool turned into an infrastructure and safety philosophy. As an added benefit, it helps me squeeze a lot of space out of every drive. And that's what this talk is about. Zelta exists because we have a powerful file system with amazing primitives that are hard to stretch as far as they can go. But I don't need something that replaces the built-in ZFS utilities. What's missing is composition, clear output that makes sense at 3 a.m., tools that understand relationships of replicas, and workflows that handle edge cases without blowing up, and policies that make sense. I built Zelta with some specific principles in mind. It has to be permissively licensed because I want to collaborate with people freely, and I want everyone to have 0 friction using it anywhere. It has to be ultra portable, so I can save a decrepit TrueNAS server with nothing but a rescue drive and Kernighan awk. I need Unix principles all the way through, so everything composes together fluidly with other tools and scales. And I want point-of-use documentation because that's where documentation actually belongs. ZFS comes with enough foot guns, so I want Zelta to be as safe as possible. I never want to be pressured to delete something that could be important in a recovery scenario. I want flexibility, so no forced naming conventions and no required data set structure on any system. Zelta's safety and Unix philosophy extends well to many projects and environments. In particular, I'm very proud that we've been adopted by the Sylvie project, an amazing VM, jail, and storage control plane for FreeBSD. We don't have the most GitHub stars, but we have big fans in high places. Zelta's job is to extend ZFS operations to be remote, recursive, safe, and auditable. Here are Zelta's verbs. You can run Zelta usage or Zelta help to learn about them. Each simplifies 1 or more ZFS commands. For instance, Zelta match takes 5 billion lines of ZFS list and tells you in just a few lines what you actually need to know. Can I replicate right now, or am I cooked? Zelta backup does ZFS send and receive, but with divergence handling, remote awareness, and mount point safety. Zelta takes complex, error-prone ZFS workflows and handles the scary edges for you. And zprune is a new and deliberately separate command because it destroys snapshots. I wanted Zelta itself to never be destructive, even by accident. If someone runs a Zelta command and something goes wrong, I never want them to say Zelta ate my homework. So I kept the explosive bits in their own script. It also turned out to be a useful separation of concerns. Zelta prune can safely pipe retention output to other systems with minimal privileges, while zprune handles summaries and nuking. Zelta 1.2 BSDCan edition is available for preview with its intuitive new features and wonderfully boring defaults. When possible, Zelta passes through ZFS flags they influence. For example, ZFS send flags will override Zelta's defaults, and it'll enforce those flags for ZFS commands it runs. 3 filters, depth, exclude, and include, now work globally across Zelta and are much more flexible. For example, you can filter dataset patterns, which tells Zelta backup to limit which snapshots it sends. We added a bookmark option that tags the host name of the recipient host, providing a little handy point-of-use telemetry. And there are a few other new features that I'll mention during the talk. But most importantly, the majority of Zelta use cases need just 1 or 2 dataset endpoints and no switches at all. 6 years of operator feedback also taught me what makes a tool both useful and pleasant to use in production. First, predictable hierarchical option behavior, basic Unix stuff. And the other options follow that lead. We have an expressive dry run and verbose modes for every option that's proven to be a great ZFS training tool at my company. For endpoint resolution, we use a simple SCP-style syntax, so it feels familiar. And Zelta isn't designed to replace ZFS for all operations, but instead to keep the safety boundary visible. If a command starts with the word Zelta, nothing's destroyed. zprune can't delete datasets or clone origins. These safety boundaries really matter in production. Last year, a third-party update nuked a client's domain controller in the middle of the night. My junior sysadmin took the call, and this was the first time Zelta revert was used in production. Not only did she get the VM back online, but using Zelta instead of ZFS rollback meant we retained the broken version of the VM and were able to get to the bottom of the crash. I'd like to show some fancier Zelta patterns, but let's start with some basic backups. Zelta backup followed by a pair of dataset endpoints replicates the first to the second, along with all of its descendants. Here we have a production dataset on host alpha backing up to a backup server named Vault. Zelta backup alpha beta. Let's call this pair of hosts twins. They have similar hardware, so either one can be our active host for our datasets. Just repeat the commands on a schedule to keep them up to date, and you can repeat them safely no matter what state the systems are in. If something goes wrong, Zelta will tell you. If nothing's changed on the source, Zelta won't create a pointless new snapshot. It just confirms that your replicas are already up to date. Here are the commands we just used. For regular syncing, Zelta backup replicates the full history from the source to the target. We can also get more selective. In the second example, we sync alpha to Vault with the snapshot prefix daily and filter it to only send those snapshots. This can be handy if you want to run backups with different intervals and different naming schemes. A replica dataset can only receive new snapshots if it isn't modified. This goes for backups and failovers. If you want to move a dataset, use Zelta failover to perform a final sync and swap the read-write properties of our twins. Next, we can talk a little bit about dataset clones and how they help when something goes awry. Most people who hear the word clone just think about a regular copy, but a ZFS clone consumes no space. One of Zelta's goals is to make using these zero-cost references more accessible. For example, Zelta provides safe alternatives to several destructive ZFS actions using dataset clones. In addition to being free, clones are portable and can replicate to a different pool or host. You can sync one as long as its origin, the snapshot it's referenced from, is available on both sides. Replicating clones, especially recursive ones to a remote server, can be tricky with ZFS commands. Zelta provided several different options to help, such as Zelta backup origin. The practical result is that you can spin up as many independent writable versions of a data set as you want on as many servers as you want, and they only cost you the storage, storage for the parts that actually change. Let's say we need to return a data set to the state of a previous snapshot. A common solution is the destructive ZFS rollback, which destroys everything to the previous point. A lot of ZFS pros avoid this. They rename the data set to keep the changes safe and clone it to restore its old state. You can do this rename and clone tango in one step recursively with Zelta revert. We've rewound our data set, but now the target is diverged from the source, which blocks usual replication. Let's fix that. Zelta rotate, use Zelta rotate to rename our target and create a clone in its place based on the source delta. The source and target now have a matching snapshot, and replication can continue normally. Zelta rotate helps other continuity problems as well. It fixes replica divergence in 3 scenarios. If the source was cloned, like our Zelta revert example, if the source was rolled back, or if the target has diverged. It's also handy for iterative QA workflows, which we'll discuss shortly. Using everything we know so far, we can make a warm failover pair using Zelta backup commands. When data changes on alpha's data set, Zelta backup from alpha to beta will sync. But beta to alpha won't, because beta is set read-only and can't change. Zelta won't take a snapshot unless there's something new. God's own property, right? That's important for keeping sync continuity in the right direction. Now we're using Zelta failover to promote beta to the read-write copy. And now our sync direction is reversed. Zelta will no longer snapshot or sync alpha to beta. ZFS really does make this beautifully simple. Let's make things a bit more complicated. Distributed storage is OK. The title is facetious, of course. Distributed storage is amazing. They can scale massively and keep things running when nodes die. Ceph is the best choice for many workloads. But a lot of storage growth we're seeing right now, like VMs, databases, and inference, have different needs. These workloads need to be performant, correct, durable, well-tuned, and recoverable. A distributed system means that when something goes wrong, it goes wrong at scale. If ransomware encrypts your files, the cluster does exactly what it was built to do. It dutifully replicates the encrypted blocks everywhere. Don't forget about the robot army of vibe-coded script kiddies getting smarter by the day. And they never sleep. ZFS doesn't make you immune, but I've recovered from catastrophes on ZFS that simply could not be resolved as efficiently or painlessly in most other environments. ZFS is actually built for performance and durability where most of our workloads live. Let's talk about managing lots of twins with bidirectional failovers, disaster recovery sites, ephemeral containers, and read-only replicas distributed where you need them. It can be a lot to manage, especially when your different workloads need different ZFS options. This is where organizing backup jobs with Zelta policy can help. Here's a snippet of an example Zelta policy file. My company, Bell Tower, runs our policies from several hardened OpenBSD Zelta bastions to orchestrate thousands of data sets across sites. So just to note, Zelta does not need to be installed on any system that it's orchestrating. So OpenBSD is a perfect choice. Having an orchestrator that isn't a storage node is critical for security and operation clarity at scale. In our configuration, we can define any Zelta command line option at any point in the hierarchy. Global definitions by user-defined site name, DAL1 in our example, or by host. The site is the unit of concurrence. Zelta policy will orchestrate one site per number of jobs defined. If you have different patterns or multiple hosts, you can define them repeatedly, and Zelta will do the right thing. Most log messages emit directly from Zelta Backup, which supports human-readable logs or JSON. We keep our policies light and manageable by keeping source datasets, backup targets, and option lists in separate files. Here's some options describing how to name the snapshots on the receiving side and source dataset definitions. It's very flexible. This Zelta policy dry run output might not seem pretty from this far away, but I promise you it's absolutely stunning when I'm troubleshooting. Dry runs show a tidy pair of filtered source and target pairs, while verbose dry run provides the gory details of exactly what Zelta policy will run. Zelta policy runs everything defined in its policy file by default, but can be filtered by just adding a site, host, dataset, or dataset leaf name. When we're dealing with this much data, we'd better make the space count. Let's go back to 2 more cloning patterns I use. Zelta clone with 2 operands recursively clones a dataset. Cloning a pool action, cloning is a pool action, so we can only clone it locally. But Zelta clone with 4 operands also fires Zelta rotate, retaining sync continuity for itself and its clone. Both pairs of datasets, DS1 and DS2 in this example, can now function as independent units, but consume no space on either pool until they're modified. If you already made the clone and want to sync it with a zero-cost clone reference, we can do that as well. You can provide Zelta backup with an origin or target origin to replicate the clone reference on the target side. The first backup is free. -- origin is the same as target origin. They're the same. Zelta will just automatically detect which origin to use on the source side. You can accomplish amazing things with ZFS workflows based on these. 3 years ago, I was working for a financial firm who ran a full web stack. I migrated to ZFS, Beehive, and Jails. A database, web front ends, multiple back ends, and most disagreeably, 4 Windows boxes. All of it was running in parallel on a single application stack. They needed to test daily versions against real production data, multiple environments running at the same time for different branches every day. This is where ZFS really shines. The daily deltas for the QA versions were around 1% of the production total, and we got hot, independent, testable environments on a single base. Amazing. Recently, I've been experimenting with workflows using the 2 other types of iterative storage for ZFS. An exciting, somewhat recent addition to ZFS is block cloning. When you copy files or parts of files, ZFS can reference the existing blocks on disk instead of writing new ones. As with dataset clones, you only pay for the new data. Block cloning happens automatically and works between file system boundaries on the same pool. The fact that copying files no longer consumes space feels like magic. On its own, block clones provide only source-side efficiency. New block clone references must be replicated again when using ZFS send operations. There's also the new fast dedupe feature, replacing ZFS's old painful, slow, and memory-hungry deduplication feature. The new version is painful, slow, and memory-hungry, but significantly better. If you have a case where it works, it's excellent. Identical blocks that arrive from different sources only cost space once. That means you could potentially get the space saving of block clones on both sides. Here's an experimental workflow our team is working on that ties together everything we've discussed. Imagine we have a fleet of FreeBSD jail replicas. They're all regular, thick jails. They're lived in and they have changes. They're in databases and unique data. But we want updates from an origin. With dataset clones and block cloning, we can do exactly that. First, we perform a Zelta rebase. perform a Zelta rotate. Now we'll copy a subset of files back based on a mapping file included with an update from the base. That's it. We have a jail patched from upstream that retains some of its old data, and nothing was lost in the process. Another way a friend and colleague said it, thick container convenience with thin container efficiency. Of course, the most surefire way to save space is by deleting stuff you don't need. Zelta Prune helps you plan snapshot retention policies. It provides previews and pipeable output and is the engine for zprune, which actually destroys snapshots. The visuals you're about to see are real output. Blue diamonds are protected, red X's are candidates for deletion. Why do we murder our snapshots? Usually it's because we're low on space. The option prune size selects the oldest snapshots until we've freed the desired amount. 150 gigabytes of red X's of doom. What if we need to make sure we have copies of what if we need to make sure we have copies of everything? Those old snapshots might be the only copy. Adding prune guard unsynced, add prune guard unsynced, and Zelta protects anything that the target, the second operand, hasn't seen. The diamonds at the top row tell us the vault is missing history. It looks like our backup target never received the original several data sets, several snapshots. You can also prune by time or count from the time right now. Prune time and prune num. Prune time 30 days keeps 30 days. Or keep the most recent 30 snapshots with prune num 30. The default policy keeps whichever is more restrictive, 30 days and 30 snapshots. So in this example, the default options are identical to prune num 30. For more advanced retention policies and to play nice with other retention tools, you can use Zelta's universal filtering options, depth, exclude, and include, to narrow the set. Here, we're considering only snapshots that start with the word Zelta for deletion, while leaving the default 30 days and 30 snapshots. Some older snapshots tagged Zelta will get cleaned out, while a few with different names stay. In our example, the first red X at the top, must be the point where we started tagging the snapshots with the word Zelta. For aging data lifecycle policies, we have a prune grid that works similarly to zREPL's great retention system. We can define simple options like this one that keeps one snapshot per week forever. Or a complete list of data lifecycle windows. And you can make pretty much any retention policy with Zelta Prune. All the options stack. You can filter first by included, excluded dataset or snapshot names, dataset depth, and replication relationship. Then select snapshots to destroy by time, size, count, or aging retention grid. After you investigate your preferred command with Zelta Prune, execute your strategy with the destructive zprune. What it lacks for in emojis, it makes up for in showing the exact ZFS destroy commands it's about to run and a summary of how many snapshots will be smote and how much space you'll get back along with the percentages for each data set in your tree. Like all Zelta commands, they work recursively and remotely. Years of working on my own with the ultra-portable awk and shell limitations got Zelta pretty far, but it's time for the project to grow. First, we're investing heavily in Zelta, and we will always maintain a highly portable and BSD licensed version. I'm never going to give up on that flexibility for recovery scenarios. We've made some progress moving toward a professional data-driven refactor with test-driven development. Since the beginning of the year, Zelta no longer needs to be installed on ZFS endpoints. We're running low on reasons to port every feature to 1977. So we've started to prototype more advanced workflows in Ruby. This gives us the agility to add additional security features, replication hints, ZFS program workflows, and other things that are too much of a bear and born in Koenig and Awk. We also keep enhancing and adding features. Now I'd like to separate our concerns. Before we move on to talking about my approach to ZFS permissions and security policy, any questions about the iterative infrastructure concepts of Zelta?
Another question from slide 38, 36, I think it was, two back. I think you have predictions there, like estimates on savings.
Oh, yeah.
How tricky was that math? Because ZFS math can be all over the map.
Yeah, it's definitely not perfect, but so the prediction math in the prune size command is a little bit tricky because ZFS destroy doesn't even predict properly. So it's pretty close, but it bases it on snapshot used and does a little arithmetic to figure out what's likely to be saved. It gets pretty close and is basically a match with the ZFS destroy dry run. zprune just does the ZFS destroy dry run, which is close. It's not perfect, but yeah, great question. That was a challenge to figure out in advance to guess what ZFS destroy was going to produce. Yes.
What was the hardest part of this to write?
The hardest part of this talk to write?
No.
Oh, the part of the code? The hardest part of the software to write was probably some of the rotation logic. So I wanted Zelta rotate to be able to heal basically any type of divergence between any source and target, which is critical for so many operations. And the ZFS documentation is pretty clear about how the target origin works. But in a workflow where you sort of want you basically want to heal a backup. That's usually the reason why why I want to do it. So getting that right and getting that recursive and figuring it out all the way down the tree got to be a little tricky. My original version of Zelta rotate was a total mess of logic. It was just ifs from here to the end of the earth. But yeah, we've been tightening that up a lot, and it's a lot more it's a lot more precise and does a great job. Yes.
I liked your example of the 4 Windows machines that you turned into ZFS backed. And could you elaborate on that a little? Because I'm not sure I followed how you pulled that off.
Yeah. So it's actually similar to that. Picked up your question, right? Yeah. Yeah. So the QA workflow it would snapshot and replicate as an entire unit. So all of the VMs and jails were on obviously on Beehive and jail in the first place. So it was just one dataset tree. So that dataset tree, after being replicated, just needed to be rotated, and then that created a clone that could then be booted. So we just literally mounted that rotated clone, and that's yesterday's data. And then we did it again, and that's the day before, and did it again, that's the day before, and so on. So this is actually really right out of ZFS's own ZFS help documentation. It gives you some hints on how people like to do it, and we implemented the same strategy. Yes.
You have mentioned on slide 8 something with encryption.
You have mentioned on slide 8 something with encryption. How is encryption built into the Zelta program, and which tools do you use for this?
So I think I think what the mention on slide 8, I'm pretty sure was just an example of a destructive encrypted action. But I can speak to. Oh no, I'm sorry. That's wrong. Yes. So okay. So basically, ZFS send without flags or with just the large blocks flag will, if the data set parent is encrypted on the remote side using ZFS encryption, it will re-encrypt it. So by default, Zelta will try to fight you on that. If the data set is encrypted by default, it'll automatically force a raw flag to send that unencrypted. If it does not see it encrypted on the other side, or it sees it being re-encrypted on the other side, Zelta will fall back to just the compress option, so it can re-encrypt on the other side. So there is some logic there to automatically handle all of those different cases. That it's encrypted on the far side, it's encrypted on the near side. It should be encrypted on both raw. That's obviously the safest way to work, and what Zelta will coax you to do if you start with it. And then there's the re-encryption possibility that it could do that. So basically, we're essentially just dropping the raw flag. Basically, the embedded option is the one that counts. Dash embed is the option that makes the difference when it's choosing to send that data encrypted to encrypted, which is best. That's what we want. And we're actually going to talk about that on the next slide as well. Does that answer your question? Yeah. All right, so I'm gonna move on to my security model. All right. So I have the evidently rare belief that sudo is not a universal command prefix. Segregation of duties isn't a good idea, just a good idea. It's also often legally required. Here's my mental model for the 5 distinct separate privilege sets. Obviously, this doesn't refer to 5 different people or 5 Zelta installations, though it could. But we should set up our ZFS workflows so that production systems can't touch backups. And of course, backups can't meddle with production. Here are the associated ZFS allow permissions for the 5 security roles. So just another note, Zelta is built on not using root. There is no, dash, I'm not root or anything like that. It assumes that you're not root, and it assumes that you have the least permissions. And while we're on the subject, my thanks to the prolific OpenZFS developer Rob Norris, who on my recent suggestion just opened an OpenZFS PR to extend ZFS allow permissions with a new send encrypted permission that would limit the backup operator to only encrypted data sets, making it impossible for a backup operator to ever see an unencrypted stream. Coming soon. So I think there should also be, is there a destroy snapshots? Sorry, I'm singling you out, but is there a ZFS allow destroy snapshots permission? Because I think that could be handy.
I don't remember, but we already mentioned about encrypted just got opened.
Yeah.
It's in review, but it's right.
Yes, it's in review, I know. But okay, yeah. But yeah, snapshot destroy. So I think Zelta's model of having a retention system that's limited only to destroying specific things could be an interesting addition as well. All right, on to my OpenZFS wish list. Well, my biggest wish is coming true. OpenZFS community members and funding from TrueNAS is making user space ZFS a reality. This opens the doors to new portability and security options. New ZFS on NetBSD, anyone? Maybe? I don't know. Exciting stuff. I've been told my next wish list item is impossible, but I'll mention it anyway since deduplication is still a heavy lift and block clone aware replication would be so nice to have. I realize block cloning just matured 5 minutes ago, but now I want it everywhere. And finally, what if some Zelta features were part of OpenZFS project itself? Some of the replication relationship stuff like Zelta match making, and easier clone tracking, that might fit into the ZFS command stack, right? Maybe? I don't know. Let's talk about it. All right, thank you. Yeah, that's all. Any questions? Oh, yes. The most fun part, what's the most fun part of Zelta to write was the pruning system. Once I figured out that I could just spit out X's and O's to find out what was being saved and what wasn't. It really made dealing with complicated retention policies. And there's some of my clients have, sliding windows and stuff like that. So being able to sort of visually go back and forth and, which of these features do I want to steal and how do I want to anchor certain features and stuff like that. Making it sort of visual and back and forth like that made it a joy to work with. And it actually suits awk pretty well, unlike a lot of the code that doesn't really suit awk. Doesn't suit awk as well. I mean, I met Stephen Bourne at a talk the other day, and Stephen Bourne doesn't even use Bourne. So I'm still sticking with it though, because.
What does Stephen use?
Bash.
That's ridiculous.
That's what I said.
You never learn what your heroes do.
Yes.
You can repeat it. Does Zelta do anything to visualize the size of relative size of snapshots to know which ones really would give some great benefit to nuke?
So the question is, does Zelta identify snapshots to get an idea of which one to nuke? What size it is? Yeah, I was looking at sort of what size, how packed tightly together snapshots are. The prune grid does a little bit of that. You could theoretically use seconds as a window, like don't keep more than X seconds of a snapshot. So that's one way. And then I was thinking about how to deal with how many, if there's a bunch of 0-size snapshots in a row, could we get rid of them? So that's a feature that's kind of cooking right now. I was thinking about it. I do like it because on systems with 15-minute snapshots and like a billion jails, you can really get just a horrific number of snapshots, and knowing which one of those actually matter, so you can clean out big ones, clean out little ones, and figure those things out in the policy. I think would be hugely helpful. So I'll say that's on our to-do list for sure. Yes.
So you mentioned that this doesn't have to run, like a backup machine doesn't have to actually have ZFS on it. Or what did you mention? That was the portal piece? Like, have you tried running that on different systems? And what have you tried?
Yeah, so the way I didn't get into too much detail of this. The way the Zelta Bastion works by default is wherever Zelta runs, if both of your endpoints are remote, if one of your endpoints is local, it'll obviously run the commands and pipe the commands appropriately. But if the two endpoints are separate, if the two endpoints are something else, somewhere else, it'll try to do, the default action is it'll try to do a pull backup from the backup target. From the backup target, it'll pull from the source to the backup target. And the reason for that is because the storage servers in a common environment are the ones with the least the least attack surface. So since your backup server is the least attack surface, the default is that. You can switch the direction, or you could technically make Zelta pipe through itself for 2 remote systems if there was some interesting security need to do that. But yeah, it works really well with SSH agents and the command master system that's built into SSH, so it can fire all the commands really conveniently, and then orchestrate, but but sort of be the third party, the third arbiter to, which systems are primary today and stuff like that. So that's the idea. So Zelta does not have to run on either endpoint. The commands are just remotely orchestrated. Yeah. All right.
Good afternoon, everyone. I'm Shardar Kamal. I'm from the Middlesex University. Well, to be very clear, I'm not part of the central IT. I'm a member of the Faculty of Science and Tech. We look after the setup at the faculty. And today, I'd like to share the journey that we had when we were trying to migrate from VMware into FreeBSD. We actually went into Beehive. A bit about myself. I had been bitten by BSD a long time back in the 90s. It was 4.4 BSD Lite, got a bunch of disk out of nowhere, and it actually killed my hard drive because back then I was more used to Linux, which had partitioning scheme different to what BSD does. BSD label was something new for me. But I fell in love, and I had been using BSD ever since. And I love art, literature, music, good company, preferably a combination of everything. And I had been a radio amateur for quite some time. So there are lots of field of interest that I have to go through. One thing happened is when I offered to my colleagues that, okay, I'm going to do a talk, they got in touch with the legal team got in touch with me because they know me very well, and they suggested that I put a disclaimer. So first disclaimer that I have for all of you, if you're here to learn something technical, my sincere apologies, we can talk technical outside. Here is the journey that I took, and the journey has nothing to do with technical bits. So if you learn anything from here, that's on you. Don't blame me. Okay? Right. Timeline in a broad stroke. So at some point in time, like May 2022, Broadcom announced that they would like to take over VMware. And at that time, we were extensively using VMware for our entire infrastructure. We will get to that one in a bit. So we decided, because it might go anywhere, both in terms of cost, in terms of usability, and lots of other things, we decided that we will start working on a proof of concept system, whether or not we can move into BSD, preferably Beehive. And on the timeline, around September 2023, we received the go-ahead from the faculty that, yep, go ahead with this thing. But by November, Broadcom finally announced that, yes, we have taken over. So we actually bid them into getting to that bit. And technically, that is the whole presentation that we saw. There is a problem, we fixed it, all done. Right? Claps. Thank you so very much. But as we all know, you are not here to just look at this bit. What you want to know is what we had been throughout that entire process as to whether or not we saw some bitches, we saw some live bars and things like that. This is what you are here for. A little bit of background. I don't know whether I can reduce the volume of it. Or maybe I should just speak a bit louder. Anyway, thank you. So we had a very small setup for the faculty. We had about 11 VSXi boxes. We had 4 storage servers, 2 dedicated NAS servers, and a handful of switches. And occasionally, we would find devices here and there that would pop up because somebody's doing some research on something or somebody's working on something. We'd wonder, what the heck is that thing? But those things are always there to help us. Yep. I'll hold on for a moment. Yay! Thank you so very much. Fantastic. Well done. See, without the IT people, we would be so dead. Anyway, so getting back to the setup. So we had various flavors of Windows. We had Windows 10, Windows 11 servers. We had variations of Linux, Debian, Ubuntu, CentOS, you name it, with or without GUI, lots of different things that we had. And we had a lot of free BSD boxes as well, because like I said, I had been working with BSD for a very long time, and when it comes to stability or when I want reliance, that's the only thing that I'd rely on. We also had many different services, both from the core team, like the IT team offering services for the students, for the academics. We also had services that were requested by the academics because they are running different courses, different classes. So we had WebID, we had GitLab, we had web servers, proxies, NAS servers. Interesting things that nobody talks about. For example, we had freezer temperature monitors. These freezers are sub-zero, -80, -90 degrees, because we had biological samples and things like that. So all of these things had to be supported by the faculty IT team, that's us. And we had to find out a solution that would work for everybody. From the faculty, we had 5 departments, about 190 academics, around 6.5K students, and of course, colleagues and cohorts, everybody. They all used the systems as best as they could. We were literally inundated with requests and things like that. And the core tech team had 5 members. We had lots of technical tutors. I'm not sure whether you're familiar with the term. So we have academics who are actually technicians as well. So they would help us in different tasks, different activities. And they would often do it without even asking. Like, we don't have to go and beg them, please do that. They would come forward, they would help us. But eventually, the main task had to be done by the 2 of us. It's not written here, but because we didn't trust anybody else. We decided, no, keep it contained, keep it simple. We will get through the whole thing. And those of you who have not been to Middlesex University, take this as a, to some extent, correct visual representation. We are literally in the middle of a public park. So public has way of right through the park. They come, they sit around with us, they talk. Students, cohorts, they all go very well with each other. Outside the classroom, situations are very lovely. These are all very good, and as in any institute, you get 1 or 2 people who you know who they are. You just tell them, oh, you know, I saw a crow the other day, and they come up with a whole bunch of eagles flowing and doing destructive things. Unfortunately, we mentioned that, okay, VMware is being taken over by Broadcom. And that spread gradually, but exponentially to some extent. And this lovely, beautiful situation turned into this. You can very well imagine that what the heck are we going to do? So we decided, no, this thing cannot continue. We found some key players in the whole situation. We got them around, we sat together, we explained to them that nothing to worry about, we are on top of it. What normally we tend to do is, in situations like this, we have to create a business case because it has to be approved by the faculty. We tell them these are the possibilities, these are the paths that we can take, whether you approve or not approve. These are the budgets, these are the costs, lots of different things, the bureaucracy that we have to go through. And those of you who are familiar with the process, I know you love this kind of pictures, where you see that, oh, this is the process. You investigate, you develop a proof of concept, you write a business case, you present, it gets rejected or it gets accepted, whichever way it goes, then you go back to the drawing board. Do you all agree that this is the process that you follow? No? Why not? Oh, you silly. Anyway, never mind. I look at it like this. This is the thing that you have to do when you go to the faculty. You create a business case, you give it to them, you roll your dice. You can either climb up a ladder because you might have a, like, don't know, POC succeeded or extra funding approved, or you might just come down the snake for whatever reason. But normally this is what happens. So we decided that we are going to have some proof of concept systems. We have to try various different things just to be on the safe side. And things we tested, we tested several things, but these are the things that we considered that we are going to do. We need to select things that will have, to some extent, a reasonable, stable history, some kind of commitment, long-term commitment. Learning curve should be good because we have very limited number of people, limited resources. So these are the things that we had to go through. But one of the primary concerns we had is that whatever we do, will that work on the hardware that we have? Because we had very age-old hardware, and we did not want to put them through stress. And as we suggested that, yes, this is what we are going to do, of course, our lovely colleagues came up with different ideas or different suggestions. Somebody asked us that you should be using Linux with Kemo. We had people who said VirtualBox is the best thing. We had people who said VMware is the best thing to go, or maybe with do something else. Windows servers, we had that suggestion as well. Now, you might think that this is getting out of hand. It is still not. The crux of the thing that came to us was this. when somebody said, well, I know somebody who knows somebody else, and that somebody else knows somebody else as well. And then this is the solution that whoever that person is has suggested, and we are going to go to the board with that. And you start thinking, oh, what have I done? But anyway, we went through all of that. And we decided that we are going to focus on a certain number of possibilities, even though it's not really, some people say it's senseless, it's not. And we, to some extent, agreed on doing certain things in a finite manner. So we decided no appliances, because we had challenges with appliances in the past. Many of you know about the NAS boxes that changes names every now and then, which used to be free, now it's commercial and whatnot. So we decided no appliance at the moment. The challenges that we had, we did not have any spare hardware. Because it's a faculty, we are limited, and we do not have extra funding. So whatever box we had is whatever box we had. So we juggled things around. We moved all the virtual machines from one box to the rest of the box, distributed them, freed one up, used that as a test box. But we needed the actual virtual machines to replicate it, because we had virtual machines which relied on the UUID or the Ethernet controller or different services that where the licenses were stuck with certain parts of the operating system. So unless we could do one-to-one replication, we could not really confirm whether that is going to work on the new system or not. And that was one of the several challenges. We also had challenges where the disk images, we could not convert them. We tried various different ways, but going from a VMDK into a Beehive backended, either an IMG or a ZFS, which we wanted, that proved to be quite a bit of challenge. And we also had the problem that we had MBR machines, but we wanted everything to be on EUFI. We had to sort all of these through bit by bit. And we wanted, well, some of us wanted reproducible automation, whereby we could just click a button, everything gets replicated from host to the target. The host gets shut down, the target gets running. We went to some extent, not entirely. Now, things that we looked at Linux with KMUKVM. It has long-term commitment, which is good. Learning curve was moderate, and cost was free. So everything was OK. The problem came when it came to Linux. Now, I know a lot of you love Linux. I love Linux as well. But for me, I still cannot comprehend why something that is running so beautifully on, I don't know, maybe Debian does not really work that well on CentOS or Red Hat. They're all Linux. They're all supposed to be the same. It's supposed to be the same code libraries, but obviously they're not. So we looked at it. We put it into the site as a consideration. We also tried SmartOS, and SmartOS was fun. The challenge that we had is we could not really find any documentation or any solution through which we could pass through our devices. We had a few boxes with GPUs, high-end GPUs that were used for various different research. We could not pass them through. So PCI pass-through was a challenge. We had Beehive. It did most of the things well. We sadly did not try the GPU pass-through, but most of the other pass-through that we tried, it worked. So it was fun. And of course, because we are using FreeBSD, well, to some extent, to various of our core systems. So I was happy with that. We looked at NextBSD, but I suspect the person that we requested to look at it might not have had enough time to go through the whole thing. So we did not really get a complete picture, and we, to some extent, ran out of time to test it further. So we left it as it is. But the final push was that FreeBSD had a lot of documentation. In my personal experience, it has the best possible documentation that you can think of all over the world, all over the internet and everywhere else. And because I had been pursuing other people to use FreeBSD for many, many years, so of course I had a good support base that, OK, if something goes wrong, at least I have people I can rely on to look after things. And our current knowledge and expertise was good enough at that point. So we went back to the system, whereby we would propose a solution, and then we talk to the faculty whether or not we can actually deal with it. And this is what happens. You go there. You sit on the other side of the table. Now, in all fairness, these people, at least in our faculty, I don't know about wherever you are, these are some of the loveliest people that you can meet outside this room. You have any problem, you go to them, they will try their best to help you. And this is a fact. This is not buttering people up. This is a reality. These people got to this position not because, well, I don't know how they got there, but many of them I have come across that they are very supportive. They will tell you exactly where to go, what to do, who to talk to find a solution. But when you are in this room, this is what they are. Because they have a responsibility to make sure that you did not come up with a half-baked solution to spend a whole bunch of money and then get away with it. They have to make sure. These are the guardians of the faculty. So they have to be very protective as to what they do, how they do, and make sure that you are not, who do you think, send me to the legal team. Anyway, so they also heard about the things that other people suggested, like, why don't we use Windows? Why don't you do that? And going there is not just about, here's the solution, let's make it work. It's about, why are the other solutions not working? Or why did you not consider the other bits? And we have to go through all of that, not just once, a couple of times, because sometimes they go back, they think about things, they come back to you. And then when they ask you all of these questions, you use the magic word. It's going to cost you a lot of money. And that helps sometimes, not always, because then you have to prove why it's going to cost more money than the other bits. So it's a never-ending game. And as you are playing that game, at some point in time, the unexpected happens. You get approved. Happy days. And the following day, the unforeseen happens as well. So the POC system that we were using, that was a very old hardware, it died. And when your POC system dies, what do? You have to go back to the game. Because now you need funding for a POC system, which is totally separate from the other thing. But you have to go through the whole thing. And somewhere in about 5 months' time, we did get the approval that, OK, now you can buy the POC system. And the unforeseen continued. We got a brand new shiny box, and the storage controller did not work with FreeBSD. Well, it did work, but it did not work the way we wanted. The new controller that came in, it had enforced RAID system. I wanted ZFS, so I wanted to have. So what I had to do technically is create a RAID 0 for all the disks, put ZFS in it, and then with every boot, the ZFS would break because Dell's card is doing something in the back end, and my FreeBSD is trying to do something else in the other end. Thankfully, the vendor was very supportive. When we explained to them what the problem is, they sent us a replacement very quickly. And we were happy. But the GPUs that we had, we could not make the GPU pass-through work. It was not a happy day. Thankfully, we did not have too many. So we decided we will follow the golden rule. And the golden rule is, when it comes to a quick fix, you have only 3 friends. Who can tell me who the 3 friends are? Guess? Any wild guess?
Yourself.
Oh, no. It's not that much thingy. But yeah, you have the ingenuity, you have the duct tape, and you have Velcro. And I kid you not, this is a subset of the different kinds of Velcro that we have in our office. This is from our own collection. So we decided to do the right thing. We got things working. And because we managed to do things in good time, we were praised by the faculty. We did not get a raise, sadly. We did not get any bonus either. That's another sad bit. We requested a few more equipment that got denied. And we did not get much firewater from the faculty, which was the saddest part. But at least we did get recognition that, yes, we helped the faculty to save a whole bunch of money. To give you some idea as to the proportion of what has been saved, I do not know who made the deal with VMware when the faculty actually got the VMware, for those 11 boxes, we were paying silly money. Literally almost nothing, because we had a few courses which had VMware as a component of the course. When we requested a quote from Broadcom later, it took us a long time because we pursued them for almost 2 years to find a quote, like how much are you going to charge us? Eventually, for those 11 boxes, they wanted to charge us somewhere in the range of £80,000. I don't know how much in Canadian dollar. I guess it's almost double, plus VAT, which is another 20%. So almost £100,000 that we are talking about. And faculty was not going to pay £100,000 per year for this particular task. It was not, yes. That was an annual subscription that they offered us. We tried to say that, well, we are an education institute. We teach part of your things. Nah, doesn't matter. Anyway, so things happened. Things ended quite happily for us. We did manage to save the faculty a whole bunch of money and got the recognition. And then came the question as to what next. So we are still on the what next phase. We do intend to look into this entire system slightly differently, primarily because managing an infrastructure in-house is required, and we are going to do it for much of the things, but there is a lot that we can actually push out to the cloud. That is what we think. We also think that a lot of resource, even though we have very limited resource, but we are not really making 100% of it. So we would very much like to look into how further we can improve that bit. Thoughts, ideas, suggestions are always welcome. And the last bit that we intend to do, from the faculty at least, is that we would like to increase our scope, because right now we are going through, to some extent, a bit of change in the paradigm. So lots of the faculties, other faculties are also looking into the possibility of using our resources. And as you all know, one of the more practical buzzword nowadays is AI. So we are trying to figure out how we can incorporate that bit into our area, not necessarily for automation. No, we don't trust AI that much, at least not yet. And that brings me to the end of my presentation. A few credits. So images were, of course, I don't draw, trust me. They were edited with Photoshop. Screenshots were taken and then edited. Music is from Hariprasad Chaurasia, Buddhaditya Mukherjee, Luna Getica, Verdi, George James, Bach, and edited with Audacity. And my colleagues, friends, they helped me to put everything together to keep it contained. And the special thanks goes to the audience. I honestly did not expect so many people. I was hoping that most of you would be somewhere else. Anyway, the organizers who decided to accept my talk, hopefully they're not regretting it, or if you're regretting it, keep it to yourself, don't tell it to me. The faculty, because they allowed me to do things that I love doing. And of course, my friends, and who constantly remind me that as long as they're there, I don't really need enemies, they're good enough. That's the end of it. Thank you. Yes?
Did you look at FreeBSD Zen?
I did not. I did not realize that FreeBSD has a Zen. I thought that Zen is a NetBSD component and you cannot get out of it. But thank you for suggesting. I will definitely put into my to-do list to have a look for the next iteration. Thank you.
Please repeat the question for the stream.
The question was whether or not I have considered FreeBSD Zen. And my response is that no, unfortunately, I did not realize that it was there. Yes?
It's not a question, it's a comment that your office is not that tidy.
Oh, don't share the secrets with everybody. See, this is what I say. With friends like them, who needs enemies? But thank you. Any further question? Yes.
So I wonder if you can, with Zen, there's two completely different APIs and management planes for it.
Mm-hmm.
There's the sort of Excel one, which FreeBSD and NetBSD use for their DOM zeros, and then
Mm-hmm.
the Zappy one, which was originally from Citrix Zen server, which was then open sourced, and then you've got XCPNG, which is the fully open source implementation of that, which was full management suite and also VMware migration tools and commercial support if you need it. I wonder if you considered that, because that's a very mature solution.
I honestly have not. Whatever I have listed are the only things that I have tested or thought about trying. A, maybe I did not know about that. B, even if I did, remember, there were just 2 of us having to deal with the whole thing, and we had a very limited time frame because we knew that whatever solution we come with, we have to take it to the board to make sure that they get it approved. And that approval has to come before the takeover of the VMware by Broadcom. We, to some extent, were running against clock. We did not even know when the clock is going to stop. As I have mentioned, that I have been pursuing VMware, Broadcom, and Dell, all 3 companies. I can show you the email threads. Every month I'm sending them a reminder. Can I please get a quote, an idea? Nobody is coming back to me. And I did not want to be in a situation whereby Broadcom says, oh, from tomorrow you have to pay for the license, whereas I do not have a solution, and I have to continue with all the academics and the researchers, whose work is, of course, very important. So I tried to limit my research to things that I knew, or things that I knew is likely to be working. But good suggestion, and if you don't mind sending me an email with your thoughts, then I'm happy to look into it for next iteration. Yes?
When you were still on VMware, was live migration part of your workflow?
Please repeat.
When you were still using VMware, was live migration something that you were using in that phase?
Right. So the question is, when I was on VMware, was live migration part of my workload? We could not do live migration because of the disk changing different shape and form. So we had to do it slightly differently as to doing a live migration. Instead of doing a live migration, we had to go through an offline period. So for a system, depending on the disk size, it could be anything between half an hour to 3 hours. And we had to negotiate that with the users. And thankfully, most of our users, except for the academics, they were OK. And for the academics, we actually had to shift it to the summer period when we don't have students. So we negotiated and we did manage. But no, we could not do live migration.
Clear, thank you.
Yeah, no problem. Yes?
So for the PCIe pass-through that was difficult, did you have use cases other than GPU pass-through?
We did try Ethernet pass-through, which seemed to have worked quite happily. We did USB pass-through. That also seemed to have worked. That gave us the confidence, oh, it's going to work. We honestly did not anticipate that it's not going to work. Sorry, yes. Yes?
How are you managing Beehive?
The question is, how am I managing Beehive? The answer is manually. I'm still waiting for the project to come to a situation. I understand that Beehive now has an infrastructure model whereby I can have a GUI or a web-based component and do stuff. I have not gone into that bit to look further. I have automation, so my automation takes care of the Beehive platform for all of those things. And to some extent, I'm OK with that for the time being. Any further questions? Yes?
What's your networking setup like? Do you pass NICs through to the VMs?
No.
Do you tap them or?
No. So I have, well, I don't do tap thing, I do bridge. So all of my boxes, they have multiple NICs because we have 4 different networks that we tap into. Yeah. So we have the public IP, private IP, management, and internal. So those individual NICs gets into a bridge. The physical NICs get into a bridge, and the virtual machines have virtual NIC, tap NICs that goes into the bridge.
Do you not have any performance issues with that?
Thankfully, no, not yet.
Because the performance of tap into Beehive is kind of sad.
It is very sad, but then again, we have very limited users.
Yeah.
And most of the cases that we had, even with 100 meg or even gig transfer, we did not really face much challenge, not yet.
All the better.
Yes. Well, it has not come up as a challenge yet. Any more questions? Yes.
On which storage technology was your old VMware system based? Do you use things like BSDCan or NAS? Or
No. So the question is, what was the old on the VMware, what was my network, storage technology? No, we just had local storage for most of the systems. We did not use vSAN, and we definitely did not use much of, well, we used some of the NAS boxes as NFS clients or NFS shares, but beyond that, there was not much challenge. It was the disk image transfer that was the challenge, because VMware does VMDK. And when you're trying to convert a VMDK into something that Beehive can understand, that there is no clear path, and there is always additional challenges. Yes?
Can you tell us a little bit more about your approach to automation?
At the moment, we are using Ansible, and Ansible is taking care of a lot of different things. We are looking into moving to Salt. And I don't know whether you want any more details or anything else you're trying to understand. No?
No.
Okay. Yeah.
What solution you use?
No, we are using, well, we had been using Ansible for quite some time, and we were happy with it. So all we had to do is just make sure that whatever playbook we are creating or whatever role we are creating, they can be agnostic to whatever host we are going to. And that happened quite happily. That was not a challenge, so to speak. Nice. Yeah, thank you. Any more questions? No? In that case, I'd like to thank you all. Anybody? Oh, sorry. Yes.
You mentioned before you must convert VMDK into a Beehive readable format. How do you do that? And what was
I did not.
Not?
No, that's what I said, that was a challenge, so I could not do that.
Okay.
So we had to take a different approach. You want to know the approach? I was trying to get rid of the technical bits, but anyway. So what we did is we actually took a snapshot of the system, took it into a different machine, and then ran privately, in a private network, a virtual machine using the VMware player. But we booted that disk into Clonezilla, and our target machine was also booted with Clonezilla, so we could just clone the disk from one end to the other. It sounds simple, but imagine that you have MBR system that you're trying to go to UEFI. That's not going to happen because the UEFI will not boot your MBR system. So we had to go through multiple iteration of the original machine to make sure that the disk is ready to be booted with UEFI before we could actually start sending them back. So that is what we had to do.
So there was no easy way to convert it from VMDK into Beehive?
I could not find one.
Okay.
I'm not saying there is none, because I tried everything that I could think of, my imagination could take me through. I failed. So I took the approach that I could manage and I could get with. If you have a better solution or a better option, I'm happy for you to share.
I'm also searching for this.
Yes.
My company, we need to convert it daily, so yeah.
We offer consultation service, by the way. No, it's okay. Yes?
You're asking how to convert the image formats?
That was part of the thing that we were discussing, because I could not find an easy path to go from VMDK into ZFS-backed Beehive disk image.
I think Kimu has a conversion tool and or virtual box.
Kimu has a conversion tool. I accept that. Does it work? Unless you have tried it, I have tried it, it didn't work for me. It might work for you, and all the best if it does. I tried various different formats, like even I went through intermediary steps from one format to another to Beehive. None of it worked. I spent quite a good amount of time with that. But if the thing, this is about a year ago, so within this year, if something has improved, I'm happy. Yes.
So there's a guy that, a Unix guy that works for Windows that built a thing he calls sysinternals.
Yes.
And he has one called Disk2 VHD. I've used that before to take a physical Windows machine, turn it into a disk, and then I can run that.
I did try the VHD method. For some reason, it did not work. But I would suspect, because I had MBR-based systems, where I was trying to go to a UEFI system. That could have been one of the reasons. But the only practical solution that I could find was to convert everything before I need to migrate and then migrate through using the Clonezilla. That worked for me.
Okay, and then if you are going to switch to Salt, I use Salt and Ansible. Salt has a Salt master, and if you upgrading it, you're going to need to upgrade the Salt master first.
We have not gone to the Salt yet. We are looking into it. So yes, but thank you for giving the heads up. I'm definitely going to look into it.
Yeah, because otherwise your minions will get all something will go wrong, and that'll be the reason.
Okay, thank you for the heads up.
For questions like these, there is a Beehive production user call every Thursday. All are welcome.
If you gave me that link, I could have put it up there. But there's still time. Thank you. Any more? Yes. Any more questions?
It runs itself.
Nope. In that case, thank you, everybody. Thanks for being here.
Check, check, check. Test, test, test. 1, 2, 1, 2. From here, farther away. Need to bring it closer to my mouth. Good. Okay, great. Thanks.
Alright, so you got your microphone there left over here?
Yes, perfect. Thank you. Yeah. Thanks.
Oh, they did a retro.
Do you have any? I was delighted this last year. I got a it's my largest composition.
You're leaving? Oh, you're not here tomorrow. You're not here tomorrow? Okay. We'll see. You're leaving Ottawa? Okay. I guess you're gonna miss half the talks. I guess you're gonna miss half of the talks then if you leave today, because there's talks tomorrow as well. A whole bunch of talks. I don't have a schedule, but it's online. But there's a full day of talks tomorrow. Yeah, yeah. So if you have the option to stay, and you can watch them online. Yeah. I guess you could talk to the tech people to see about watching tomorrow's talks online. I guess you can talk to the tech people about watching tomorrow's talks online.
Yeah, here it's 30K.
Sometimes it's hard. That's why it's important to make it online. Like, I don't know if you've done it before. For me personally, I've watched videos. The video is not good. It's not good.
Mm-hmm. Starting soon.
Yeah.
7 seconds. 70. Okay. Perfect. Okay, great. Not an exactly ad, but within, more or less. All right. All right, good afternoon, everyone. All right, so we have a bit of a story time. So as my slides indicate, tell us how hard could it be modernizing SigmaNAS
for OpenZFS 2.4.0. Right, and for some of you, you might be wondering, like, what is Sigma NAS? Well, it's an open source NAS operating system based off of FreeBSD, which means it was descended from BSD, which began as UC Berkeley extensions to AT&T Unix. Actually, I probably don't need to go through most of this with the people in the room here. But eventually, there was FreeBSD, and that was the base for monowall. But what about FreeNAS? Well, a lot of you probably have heard about FreeNAS. Can I get a hands to, you've heard about FreeNAS? Yeah, okay, great, awesome. And, but then, like, wasn't that the base for what was TrueNAS? And then we'll started where I started when I came in the picture. So our story begins with a question that we have all asked ourselves at some point, a question that has launched more doomed projects, more late nights than any other. And the question is, how hard could it be, right? In my defense, I wasn't trying to do anything crazy. I wasn't doing any kind of kernel development or making a new distribution. I just wanted to upgrade my NAS. And Sigma NAS generally tracks FreeBSD versions, right? So 13.x is 13x for FreeBSD. And this was back in the summer of 2024. I was running Sigma NAS 13.2, and there wasn't a 14.x release yet, even though FreeBSD 14.0 was already out for 7 months, and then 14.1 had just dropped. And I thought, okay, well, it's open source, it's PHP, like, I know some PHP, like, why don't I just build the release myself? Like how hard could it be? So download the source, like, run the build script, call it a, and that took more than a day. And what I didn't appreciate is that Sigma NAS, it's not just a project, it's an archaeological site. It's a living museum of assumptions, build scripts, make files, port options, and historical decisions whose original authors have long since ascended to a higher plane of existence. So here's some history of FreeNAS, which was the, where Sigma NAS kind of carries on. Began with, you can see, monowall back in 2003, and it was targeted for embedded firewalls, very low specs, right, based on FreeBSD 4.7, which later had FreeBSD 6. And around this time, which is kind of interesting, let's see, where FreeNAS started, 2005, do I have a date there for FreeBSD? It was based off FreeBSD 6. So actually, because the RCs for 6.0 were actually quite stable, sorry. FreeNAS, come on, cancel, that's right, so embarrassing. Was based off FreeBSD 6. And around the 0.7, there was a fork in the system, and they decided, one of the developers decided they wanted to do their own NAS based off of Linux, and then they ended up producing Open Media Vault. And back with the FreeNAS in the 8.x, they decided they wanted to rewrite in Django. Further down the line, after IX Systems kind of took charge of TrueNAS, of FreeNAS, it became TrueNAS. There were different versions. We had the FreeNAS 11 series. There was a TrueNAS Core, which is based off of the original FreeBSD, but also they had the TrueNAS Scale, which is based off Linux. And after the TrueNAS Core kind of, I don't know the appropriate word, maybe just kind of fizzled, the community came up with a fork of TrueNAS Core called ZVault. I don't know too much about that. But this takes place back in the original FreeNAS 0.7 code. This was originally written in PHP. It was maintained by some of the original developers back in the day, and they renamed it because IX owned the branding for FreeNAS, and they called it NAS for free. And eventually, that was back in 2012, eventually they renamed that and protected it with a trademark, Sigma NAS, which is trademarked since 2018. And I came in summer of 2024 and started doing some work. Right, so I thought, okay, how do we get started? Luckily, there's a guide, quick start guide for developers, not really me, but interested users. Yeah, okay, that's me. And the process of this documentation was basically, you set up they recommended a virtual machine to do it, install FreeBSD, and then you just build ZigmaNAS, right? Just 3 steps and you're done. Okay. So open up the documentation. On the quick start guide, it says, oh, okay, well, this will use the current ZigmaNAS version based on FreeBSD 11.2. And this is like based in, like, which was released in 2018. It's like, okay, well, it's a little bit old, but you know, maybe it's just a program that runs on top of FreeBSD. We'll see how it goes. And it guides you through creating a virtual machine. They recommended 1 gig RAM, 35 gigabytes of storage. And since I was running ZigmaNAS at home, that includes VirtualBox and a front end in PHP using PHP VirtualBox. I'll self-host in my basement. I'll do the ZigmaNAS development in my basement using what's already there. All right, so create a VM, and from there, the next step is to install FreeBSD. Amazing, great guides. For this project, since 14.1 was out, I decided, okay, I'll just install 14.1, and then after you install it, you update it. All right, going through the process, recommend you do FreeBSD update, fetch, install, and probably nobody here has a problem with like recognizing the prompt from your pager, but if you are new to Unix, right, you're just like, okay, update, go, a lot of stuff happens, and you're like, oh, it's still processing, right? And it's like, yeah, because it's user-friendly, it tells you colon, right? It's like, okay, I'm done, right? I'm like, no, you gotta like quit that before it's telling you what's gonna be upgraded. After you update the system, you need to install some packages that it uses. It actually recommended ports. And so part of the build system, it uses bash, port upgrade, CDR tools for building the ISO, and for version control, it uses subversion. Right, so then if you're new to this whole world, you're like, well, like, what is the port? Good thing is FreeBSD has an excellent handbook, and it says, a FreeBSD port is a collection of files designed to automate the process of compiling an application from source code. The files that comprise the port contain all the necessary information to automatically download, extract, patch, compile, and install the application. Okay, so this is great. How do we get it? Okay, looking at the document. All right, port snap, perfect. Let's run port snap. And we get this, command not found. We're like, oh, okay, no problem, I'll install it. Install port snap. Oh, it's there, it's deprecated, okay, great. And we run the extract. It's like, okay, the prerequisite directory is not there. So just some little speed bumps along the way of trying to build this. Even get our host environment, our VM started, right? And proceeding, alternate ways to get the port straight, right? As of 2021, Git is the primary way to get the ports collection, as most of you probably already know. And in addition to that, we also need the source code for FreeBSD. So how do we get that? All right, going back to the quick start guide, CVS up. Longer story short, that kind of migrated to CSUP. There's time for subversion, but then it's recommended to Git. Finally, we get all our source code for FreeBSD. We can compile it. Now let's move on to ZigmaNAS, the actual source. We install Subversion, we check the repository, and we're gonna build this thing, right? How do we build it, right? Most programs, you think C, it's like configure make, and it's like, okay, let's run make.shell. It's a big bash script. All right, so let's run it. What happens? It's gonna compile everything, build everything, and give us our image, right? We run it, and we get this, right? Kind of a choose your own venture on the menuing system, right? Here are a bunch of steps that you need to take, and you're going to produce your ISO file, your image file. And as you iterate through the numbers, a lot of it's spent in the compile menu, number 2. When you, there are different options for the different types of images. So I'll talk more into the mic. Types of images that you want to produce. I got number 10, the embedded. You got live, USB, CD, etc. But you spend a lot of time in number 2 under the compile menu. When you're compiling, we have a lot of different things you can compile. You can upgrade the FreeBSD source tree imports, which we already did, but if you wanted to do it this way, it's kind of a menu-driven way, a little bit more easy for things you might do regularly. You want to build the file system structure. And most of this is just hitting the numbers, going through the menus, and it does everything pretty much automatic. Come to number 6, the ports. That's a lot of the time spent building any kind of distribution is building the software. There's a huge amount of software, right? So you pop in the ports menu, and for the most part, you just go through all the items, right? Some of you may have seen this if you're familiar with XKCD. So while building the ports, all the ports required, I came across this. And if you're a PHP developer, you're like, oh, that's clearly not PHP, right? You're like, what is going on, right? And like, I just want to compile this. There's like there's a port. There's a problem with the port. Foops, I don't know how to pronounce that. And possibly there's an undefined macro, maybe not. So going down a bunch of rabbit holes, figured out that, in the port, it assumed that you have a bunch of things installed, and it was missing libtool, automake, gmake. Finally got that resolved, and going through fixing that port, we came across a lot more compilation. Some things went really well, some things took a little bit of work. Side note, there's gonna be a lot of side quests here. Not all installations will include some version of dialogue, which is kind of required, star. And then while compiling things, a lot of it was not speedy at all, right? So we encountered our first kind of dragon. All right. Does anybody actually know, I guess 2 things? This is kind of a mashup of 2 images. Does anybody know either one of these images? What's from? Final Fantasy 1, yeah, awesome. And the kind of creature there, does anybody know that?
Is that from Razer? Is that like from the brand Razer? That makes like mice and stuff?
Razer? No, good guess. It's actually,
The logo of LLVM?
correct, yes. Yeah, LLVM, yes, correct. Yeah, so Wyvern, and so as I'm compiling, this is on a VM single core with, how much RAM did it recommend? 1 gig of RAM, right? 1 gig of RAM on virtualized I/O. Not. Yeah, right. So 1 gig of RAM. So this was not speedy, and then I go to my terminal and I see like, okay, what's going on? It's building LLVM. I'm like, why do I need LLVM for my NAS? And it's like, oh, it's because it's part of like Qt 6 tools, which is part of like VirtualBox, which is required for the PHP VirtualBox. I was like, what? Kinda, I guess. I mean, okay, sure. So building through the ports, if you're not really aware of what you're doing with the ports, you can make some mistakes and some missteps. And because I did kind of mention dragons. There we go, dragons. You come across the xterm source. Because you are dealing with X, if you take a misstep, you can compile X, Xorg apps, which includes xterm, which has this little snippet of source. And that's not the only dragon kind of counter. This is kind of more playful. Through the FreeBSD source, there's an old screensaver, console screensaver. This is unfortunately not included in XigmaNAS, but that's like an alternate dragon that I did encounter. All right, so going back to building. All right, after all the compilation, there were other steps along the way to build the image, and finally, going through all these steps, several days later, we produce our working 14.1 image. Yay, perfect. I'm up to date on the latest version. And I thought, okay, that was a lot of work. But what do I want to do if the next version of FreeBSD comes out, like 15 comes out? Like what do I want to do? I'm going to go through all these steps again. Is there some way I can kind of make it automated or faster or do things in parallel? And it's like, I know some shell scripting. Like how hard can it be, right? Do I just keep this for myself? Like maybe someone can like benefit from this. I can upstream it. But are they going to take some like patch from some rando on the internet, right? So who am I? Well, by day, I'm now a yoga instructor, but I used to do some PHP programming on FreeBSD, and I've been using FreeBSD on and off since like the mid-late 90s. And I thought, okay, so if I'm gonna work on this project, I wanna make sure like I'm using it, like I can't break things, right? How do I go about doing this, right? So it's got a bit of surgery going on here. I wanna like break things apart and see where I can change things, but I don't wanna actually break things. Right, so I'm trying to build automation and speed, but also there's like the social aspect. It's like, okay, I want to make sure that the changes that I'm doing are safe, like they're easily reviewable, like small little chunks, and you know, because this is a project, I want to like be respectful and just to follow their guidelines. And this came in the form of separating out the main build, the main make.sh into functions.inc, so that basically make.sh is gives me a shell that calls all the functions, and then if I want to add new functions, I can add there and then make a brand new shell script that's going to say like, you know, create everything.sh. And this is kind of where a big chunk of this talk diverges. So is anyone familiar with yak shaving? Heard of this? Yeah, so it's kind of like procrastination, or kind of these like annoying things that kind of pop up along the way that you kind of have to do, but maybe don't have to do, little side quests. So originally, I had just SSH'd in, and I was using VI, and I thought, okay, well, scrolling through this giant, actually I don't have the file size here, but scrolling through this giant file of shellcode, and I'm not super proficient, I'm not proficient at VI, and like, it was a lot. So I'm like, okay, I want something easier. It'd be nice if I had VS Code, and then maybe I could just do something like SSH, SFTP, and then just do the files back and forth. But VS Code has this nice thing called VS Code Server. Has anyone used VS Code Server? Yeah, okay. So if you haven't, what it allows you to do is there's a server in the back end of that VS Code installs, and allows you to open like a local terminal. You don't have to have like a separate like FTP client, SCP client, like I'm trying to think of like Transmit on Mac or CyberDuck, something like that. It's as though you're locally editing files. You can open up remote files when you go like click on open. You can view the files remotely. So you don't have like two different programs, and not your FTP or SCP and your editor. It's all built into one. But the problem is that it expects Linux, which this is not, right? So what to do there? So thankfully, FreeBSD has a Linux compatibility layer. So while underneath it's FreeBSD on top, it's looking like Linux, right? Like, and then the mascot is Tux, so I thought it'd be kind of cute to have BSD wearing a tuxedo. AI is kind of interesting these days. All right, so then looking online, it's like, okay, what can I do? You can make a Linux jail, and it's not quite what you think. Maybe you thought, oh yeah, I want like a VM of Linux, but it's a jail, and I can just have the full thing there. And so I kind of dabbled in different OSs, and for some like spare computers in the basement, I've been playing with Ubuntu, and so I got more familiar with debs versus RPMs. And I thought, okay, well, I'll create like a jail, and there's the Debian Bootstrap tool that will like bootstrap a directory with the files from the distribution. And then I thought, okay, well, I'll do a version of Ubuntu. I don't have the version that was supported, but it's old. And the glibc provided was not what VS Code Server required. It required 2.28 at the time. I think it's newer now. And I thought, okay, well, maybe I can also, while I'm on this path of like figuring out how to get my distro, I want something without systemd. So searching like what has systemd and supports deb files, it's dev1, but Bootstrap doesn't support that. So I'm like, okay, like how am I gonna get my dev environment set up? Longer story short, I think I took just like the Docker OCI image and then just like splatted that into the file system. So finally, I set it up, And yay, we got it working. We can finally start to look at the source code. Right? We can scroll through it, and it has nice code folding. You can see here on the bottom, we're running. I'm actually running. Surprise! I'm running 15 already on here, but it's doing the Linux compatibility. This was a VM, and I thought, okay, it's slow. I'm on a single VM. How can I make things faster, right? Instead of having just the one CPU with 1 gig of RAM, virtualized I/O, instead of building ports with just no J flag, I'm going to throw like all the J's at it, and let's build this in a jail, right? And then we can use all the cores, all the RAM. I don't need to dedicate all my RAM because I'm doing this part time. I don't want to like dedicate all the RAM to the VM, and then later on I want to do something else and I have no RAM because it's all in the VM. So I ended up creating a jail. At the time I was using QJail, and let's just go through the process. All right, go through the process. To build the image, there's kind of the way it builds it is it creates a memory device, and it creates a file system, and then it mounts it, and it copies the files over, right? But running in jail, some of you may or may not know, you get this when trying to do this in jail. It's like, oh, like it's permissions. Okay, so like I'll just maybe like add allow.mount.ufs, which doesn't exist, and which seems kind of strange for Unix, right? It's like, okay, like I'm root, and like I'm not permitted. It's like why can't I just do it? Like I have all the permissions, just like do it. As it turns out, like it's not really kind of supported. And I thought, okay, well, FreeBSD is open source. Like, can I just change this? Like, just allow it. Like, it's my own machine. I just want to build it. Like, I know I was going down to the forums and saying it's kind of a security issue. It's like, yeah, we're not going to do this. But I'm like, well, it's open source. Why don't we just do it? Longer story short, like I found out someone had posted on how to do it, not recommended. And I thought, like, I don't want to maintain a separate FreeBSD patch just for this, so I can build my system. So there's got to be like a different way. And then I thought, okay, well, it works on the base system. Why don't I just root in? The kind of minor thing I thought about that was like, oh, if I have a different file system, when I SSH in, when I use like my graphical manager, I don't want to have to go through this hierarchy of directories to get there. I want a jail for the organization, but I also want for organization, but I want a root to actually run the build. So I ended up having like just rooting the directory of where my jail lives. So I can have SSH to do the editing the files, and then I'd go to root through the host system, and then just run the build from there. So I'm like, okay, this is a bit better. And then alternate timeline. Further down, I found out, I can't remember which pod I was listening, probably listening to BSD Now, and I heard through updates through FreeBSD 15 that they had reproducible builds, and you don't need root. So I'm like, oh, perfect. Like whatever they did, I want some of that. How can I build this like in a jail? Because I want to build in a jail. And it wasn't new, but definitely new to me. They used MakeFS and MakeImage. And I'm like, okay, that's perfect. Like now I can build things in a jail. Everything's happy. But the problem is I'm still single threaded, right? It's like very manual, not automated. Like what can I do? Like what can I do how can I speed things up? Because I was doing a lot of builds, I wanted to make sure that all my changes didn't affect anything negatively. So every change I did, I wanted a brand new system. I'm going to do a reinstall, and then at the time my internet was extremely terrible. And I'm downloading all these packages. So like, what's one thing I can do to like make package installation a bit better? It's like, okay, well, everything that's downloaded is cached. Let's see if I can have this, and I'll just null mount my var cache package just so I don't have to download everything from scratch all the time. And that's going to make things a bit faster. The initial setup, right? Port snap was, I think, gone, and it recommended git clone, right? Git cloning all the ports. It's like, I don't need the entire history. And again, my internet was kind of quite slow, so I thought, okay, but I found across, okay, if you just do depth 1, it's much faster, but even faster, just for downloaded, to getting the ports free on your machine, was a fetch, simple fetch, and that was faster than any other methods. All right, okay, so that improved it. What else could we do? Right, we had to build the world and the kernel. Instead of that, even though we did update previously, why can't we just use the FreeBSD update process in the future, and then building on that, why can't we just use package base? Right, a lot of this is very manual compilation, which when you're building a distro, you probably don't need to do. Right, so we'll just use package base for a lot of the heavy lifting. And I thought, okay, perfect. Right, how can we make this better? Right, we get more horses, make it more automated. Right, and then so it turns out that like the best way to have a package compiled is to not have to compile at all. Have someone else do it for you. And we're done, right? We just install the package. That worked, but unfortunately there are some packages that were not pushed upstream to the official FreeBSD ports. And while I did migrate, I did include some of the packages. Some of the files I was manually tweaking by hand. There's a list of files, what goes in your distribution, and I had to kind of hand pick them from the packages. And then in the boot sequence, what happens is we have two kind of compressed file systems. We have our memory file system root, and then we have our user local with like basically all the packages installed, and they are of set sizes. So when switching to using packages, right, you can choose what options that you want in your packages. With building from ports, you have more flexibility. And some of the options had some extra things, so I thought, that might be nice, I'll include it. Ran out of space, right? And I didn't realize that, right? And I'm like, oh, it just built an image, perfect, let's boot it. What happens? And you get an error. Okay, not found. And I guess FreeNAS was probably one of the first, or I guess Monowell was probably one of the first distros that where the config was in XML and had PHP run command scripts. Right, so I did not get all the dependencies correct on PHP, so I had some problems. This was not nearly as bad as some of the other problems I booted. And then going back to like, how can we make things faster? How can we do things in parallel? Well, when we're compressing our image, our rootfest image for gzip, why don't we add more threads? Gzip, from my knowledge, doesn't support parallel threads, but there's a version called PIGZ, right? So I'm like, perfect, we'll use that. XZ was used to press the user line because I think FreeBSD in the embedded boot didn't support it, only supported gzip. So I'm like, okay, we'll just take that, crank up the number of threads, and we run into a memory limit, right? So to bypass that, compression level 9, T is the number of threads, 0 is all by default, and when you hit a memory error wall, you can say I want to use a maximum of 75%. To have these rapidly iterating tests, I decided, well, like I don't need maximum compression. I just want to see if it works. So found out that -1, very, very, very low compression, super fast, awesome for testing for these dev test cycles. Right? For testing, after I create this image, I want to see that it works. I need to boot it. I'll boot it in the VM. I was using VirtualBox at the time. That's I had it, and I thought, okay, maybe since I'm trying to improve things, maybe I can get it to FreeBSD using Beehive, right? That way, I can do ZFS rollbacks, and I can do a bit more automation with like rolling back my VMs and starting them. All right, so all of this eventually, oh, hang on a sec. So as kind of mentioned before, I finally did get it working on FreeBSD 15, which was the release that had open ZFS 2.4.0, and with a bunch of shell scripts running tmux. So this is a sped up version where I'm kind of compiling it. On the bottom, I've just restored ZigmaNAS, you can see it's 14.2.0.6. The top one is rebuilding and deploying. So extracting all the packages, and it's going to take what it needs from the packages, build the image, and then throw it to the VM, and then reboot the VM. All right. ZigmaNAS and FreeNAS, because it's got a web GUI, you can just kind of select which embedded image that you want to update to. It also supports a command line version, so you can do that. And you can see now we're on, back then, 15.0.0.7, all right, for ZigmaNAS. So everything which took many hours, was very laborious, very manual, I can get it down to 4 minutes and 13 seconds on my machine in the basement. All right. And then I had someone ask me, great, now that you've done all this, have you updated the documentation? And no. So as I was coming here to make a presentation, I thought, oh, it would be kind of cool, what kind of presentation software can I use? If there's something that kind of runs natively on FreeBSD. So I was looking and looking, and probably most of you have heard of LibreOffice or OpenOffice or probably StarOffice. There's something called Applixware. Has anyone heard of Applixware? Yeah, okay. So back then, Applixware, I think Walnut Creek had it on a CD-ROM, and this is a binary that I think it was made on FreeBSD 3. Yeah, so I'm like, oh, okay, well, it's FreeBSD, it's open source, like how hard could it be? Let's get to work, right? Like, I'll install compat 3.x, which doesn't exist. I'm like, oh, okay. And it's like 32-bit, but I'm running FreeBSD 1564. So this was way beyond my scope. So I asked AI. I found a guide on how to get it running on FreeBSD 6 32-bit. And I thought, okay, that's going to be a good start. How can I get it going on 6 64-bit? And an AI tool made a shim, because I'm trying to think of, some of the things have changed significantly. I think it was the etc password something has changed in FreeBSD 15 since, I don't know when the change was, but it was significantly different. So I have not yet updated the documentation because I got roped in with this side project, but then the night before traveling, I wanted to get a FreeBSD machine set up, but then it turns out that my video adapter didn't work, so that's why I'm doing it on a Mac today. So after getting everything working, I thought, okay, there is a lot of room for improvement, right? Building a distro, you're taking little bits and pieces and just kind of like mixing your giant pot. What is some future work it can do, right? Like, what are some additional things you can add? It'd be nice kind of taking inspiration from TrueNAS, if we can have some kind of apps or something, maybe do some work with Podman for managing VMs. Before it was PHP VirtualBox, it'd be nice if there was something to manage Beehive. I've been using VM Beehive. It'd be nice if there was a web GUI for that. Building everything from ports. Instead of that, try to use packages where possible, upstream the packages so we can just use the ports. Maybe even having some boot environments, modern UI. And so one of my side experiments, there's a project, I'm not sure if I'm pronouncing it correctly, Sylv or Sylvie? Sylv? Yeah, and so I did experiments with that, and at the time I didn't, I don't know if it's still the case, but while it was great as a front end, it seemed to be lacking a CLI version. So like when you create a VM or a JL, you can do it all through a GUI, but then when you're trying to like trace back to where that came from, it seemed, I was accustomed to Bastille and VM Beehive, where you have like your files that would create your VM for the Beehive or the JL, and it'd be nice to have something like that. So again, I asked AI, oh, like there's a web API, can you just make me a CLI for the web API? And that way I can have a CLI version to do all this stuff. So it's a bit easier for me to understand, but if you know how to do Beehive directly, you don't need it. And that's basically my little adventure. Does anybody have any questions? Yep.
Is there a reason you stuck to having the compressed MD route instead of just would it make sense for ZigNAS to use ZFS as his file system instead of?
Yes, yeah. So then that's one of the things I wanted to do. I would think so. I wanted to add ZFS and have boot environments as well. Yeah, and I thought, okay, instead of doing all of this work on a project that's not mine, I'm just kind of this drive-by, giving patches. That's why I thought oh, it'd be better if I could just have ZFS as exactly. Yes, I agree. And then so I had ventured into doing some stuff like that as well. Yeah.
And have you ever looked at Poudre, the tool for building ports?
I did, and that's where I came across. So when I was building stuff with packages, that's where I came across use package depends, which is a huge time saver. So normally when you build something from ports, say I want to build, so no, I haven't actually looked too much into
Poudre has a second image, image.
Okay.
Install packages. It takes care of all that kind of stuff.
Okay.
So you would be able to basically download FreeBSD from package base and use that to get the base image, and then use the make package depends to get all the ports except for any you want to compile with different default options, and then build that all into an image, kind of all already built for you.
Okay, amazing. Yeah, very nice.
It might save a lot of pain over some of the stuff you had to deal with.
Yeah, for sure. Yeah, because I was thinking I'm not the maintainer of this. I just run it in my basement for my own personal use. So it's I don't mind doing it, but then I imagine people would want to do that as well. A question at the back.
Can it be used as a drop-in replacement for TrueNAS, whatever the FreeBSD version of TrueNAS is called? I forget which one it is. Can it be used as a direct drop-in replacement? And if it can't, do you have any plans to write something for migrating so that all the lost souls stuck on that can get an upgrade?
So for TrueNAS, no. There's a significant fork back in the 8.x days. There was actually, they said it was a rewrite more than a fork, rather switching from PHP to Django, and I think also maybe the build system. I think they may have used Nano BSD. I don't know. When IX system, yeah. So it IX systems took over that, and I think they switched the build system entirely. So this is back to the old build system. So this would be more compatible with TrueNAS. Sorry, FreeNAS.
I'm more interested in installing it, and it recognizes my data sets.
Yeah.
Some of the other stuff not as concerning because it could be reconfigured.
So it could import the pool.
Yeah.
And have all your files, but you'd have to write something that would walk the silly SQLite database and extract your Samba config out of it. So that's. But ZFS means your files are all there, no matter what IX did to it.
Mm-hmm. Yeah. So this is pre-IX code base. Mm-hmm.
John would know.
Any other questions? No? Okay. Oh, yeah.
Your true, I mean, the way you discover everything is exactly the same path when I created FreeNAS.
Okay.
Exactly the same problem, the same discovering of BSD. That's fun.
Yeah, because you're like, I don't know what I'm doing. I don't know what I'm trying to solve, and I'll just just kind of bumbling my way into walls. Yeah. It's great and very comforting. All right. Thank you all.